Hello and welcome back to the channel, everyone. Today I'm going to be taking everything I do inside the Wave Game Framework series and I'm going to put it all into a single video. This is going to be slightly out of order from the recorded series, but it will cover the exact same blueprints and topics. So we have open here a new third-person project, just this empty map like normal. The first thing I'm going to do is delete these chiffon cubes. I don't want them messing with my gameplay. And then I'm going to duplicate this player start 4 times. That way I have somewhere for my players to start, otherwise they get all clumped up, and I don't want that. And we need to do one more thing in this map for later on, because we are going to have enemy AI in here. So we are going to add a nav mesh bounds volume. Nav mesh bounds volume. I know I usually click modifier on accident, so you gotta make sure. Anyway, we're gonna put this just somewhere in our map. To where it is slightly above the ground, and we're going to make the extent something like 6,000, so 4,000. 4,000 looks good, and 4,000. And yeah, I'm not too worried about it here. I just need it to be big enough for the whole arena. I'm not too worried about it being too big or anything like that. So we're going to press P here, and P is going to let us know what is available to walk on. So right now it's too high. And we want to make it a little bit higher so they can get up there, so we're just going to make this 300. And now everything is green, so our enemy can walk around this map perfectly fine when we make them. We're going to need 2 actors, basically, to control things inside of this map, or whatever map you're going to be using. But the first thing I'm going to do is make a new folder and just call it Wave Game Frame. Something like Wave Game Frame, and give it a color. That way we can easily access it later on. So now I'm going to open that up, and I'm going to add another new folder called Actors, because this is going to be for the actors in the world. And we're going to create 2 actors in here. So new blueprint class, actor, and I'm going to call this one BP Pool Locator. And I'm going to call the other one BP Spawn Pad. So Pool Locator is going to be very, very easy. We're going to come into the class defaults here. We're going to search tags, and we're just going to give it a tag of Pool Locator. And you could add this Pool Locator tag to any actor in the world, and use that as a Pool Locator. You don't need this Pool Locator actor. Just something with a tag of Pool Locator will work with this system. The spawn pad, though, we actually do need to do a few things in here. So how our spawn pad is going to work is it's going to use a blueprint interface to basically determine whether or not it is active. So we're going to add a new boolean here called active. And we're going to need to set this boolean from the game mode when we decide which spawn pads are going to be active. Because we're going to have a system where the spawn pad can be active or deactive based on what the game settings are. We don't always want all of the spawn pads to be active or deactive, right? So we also need something in our viewport, and I'm going to add a sphere collision, and I'm going to make that the scene root, and then I'm going to add a static mesh in there of, I guess, a sphere. And we'll make that sphere tiny, let's say 0.2. It's just something to be in the world for me to drag around and basically be able to get, so basic shape material is fine. We do not want collisions, so the collision presets here need to be no collision, and you'll probably have to open it up anyway and say custom, just to make sure that we are not colliding with anything at all. And we want this to be hidden in game as well, because we do not want to see it. Okay? And this is really just for the sphere collision. This is so that we can test and see if the enemy is sitting on top of this for too long, and do something with them, right? So that is going to take this on component begin overlap and on component end overlap from the sphere collision. And we don't have our BPI or anything like that yet, but just know that we will be branching, and we'll come back later when we have our BPI from our other actor. Promoting this other actor to a variable. Just other actor is fine, if this is true. We're going to set another boolean called occupied. So I guess I'll add a question mark. Another boolean called occupied to true. Whoops, that's not what I wanted. because now we know that something is on top of this sphere, so that is true. And then we're going to do the same thing down here, except this is going to be if other actor equals the actor that's currently on it. Okay. If that equals the actor that's currently on it, then we want to say, okay, the enemy that was standing on top of this spawn pad and not moving has moved, and we're good. We're no longer occupied. We no longer have a valid other actor. And we can go ahead and do stuff with a debug timer, which we're going to make just right now because it's pretty easy. So I'm going to make a custom event here, and I'm going to call this run debug check timer. And I'm going to make one more called clear debug check timer. So clear debug timer. That way we have a way to run and clear this from right here. So we're going to say run the debug check timer when it's occupied, and clear the debug check timer when it is unoccupied. And this debug check timer is going to be really simple. Run is just going to set timer by event. We're going to need this timer handle in order to pause, so we're going to call that debug timer handle. And basically, we're going to make a custom event check debug. I'm going to run that every 5 seconds and call it looping. And we're going to use escalatory logic here. So we need to take occupied. So get occupied. If occupied is false for whatever reason, we need to just clear the debug timer. Because it's no longer occupied, something has happened. Maybe the timer has ticked while occupied has decided to become false. We just want to go ahead and clear the timer. And we're going to need another variable here called escalations. And that's going to be an integer. And all we're going to do is get that and get it and increment the integer. So it adds a 1 and then sets escalations. We're going to check and see if that is greater to or equal than 3. Greater to or equal than. Because we're going to use 3 escalations here. So the first time this loops, it's going to go from 0 to 1. The second time it loops, it's going to go from 1 to 2. And the third time it loops, it's going to go from 3 to 4. So... and then we have methods of basically handling the enemy death. Here I'm just going to print a string and say escalations reached. Because we're not going to have our enemy BPI yet. And then we're going to clear the debug timer. And we'll get into this print string eventually, but basically this is just going to be where we call something on the game mode to tell it to remove the enemy from play. The enemy is bugged, they're stuck, they've gone through this escalatory process. For 15 seconds, we want to get them out of here. Clear debug timer. The first thing we need to do is set escalations to 0. We no longer have escalations, and then we take our debug timer handle, and we clear and invalidate the timer. And that's it. Just making sure that we stop the timer and reset escalations. Because we're done using it, it's over. So I'm just going to comment these. These are done, pretty much. And I don't think this matters too much right now, I'll be honest with you. Having this debug check timer, but I know from experience using a system similar to this, that it is very, very useful later on when the AI starts bugging, and you're trying to debug and you're trying to figure it out. And you have like an AI who for some reason just gets stuck and doesn't know what to do as soon as they spawn. This will just let you destroy them, pretty much, or respawn them. So the only thing we're waiting on this onComponent begin overlap sphere is the BPI for damageable, and we have to make our BPI for the spawn pad now anyway. So we're going to open up a new folder, call it interfaces, and we're going to make 2 BPI. We're going to make a blueprint interface, BPI pads for the spawn pads, and we're going to make another one called BPI damageable. And that is going to be for the enemy. We're not going to worry about damageable right now. We're just going to save that and close it out because we don't need it. We just need to check here on the overlap component, or I'm sorry, here on the other actor on the sphere overlap. Say does object implement interface, and that is going to be the BPI damageable. Sorry, my computer just made a really weird noise. Kind of scared me. Yeah, so we're just going to see if it implements the BPI damageable, and then if it does, then that is a enemy actor, right, for all intents and purposes. If you have another way to signify enemy actors, then use that, but this is just what this does. So these are going to be The collision sphere events for running the stuck timer, and basically you don't even honestly need to do this. This is more or less just kind of things that I like to do to make sure that we have some scalability in the future and we don't have to like come back in here and write all this stuff whenever we need it in the future. It's already kind of done for us and we already have it, so we'll likely encounter fewer problems, or at least know when we encounter them this way. So yeah, now I am going to take this active timer and we need to do something with this, right? This active boolean, because we haven't done that yet. And that's all going to come from the BPI. So we need to start making our BPI for our pads. So the BPI for the pads is going to have a few functions. 3 of them are going to be getters and 1 of them is going to be a setter. So 1 of them is going to be iSetIsActive. And I try to always prefix my interface events with an I, and I always also try to categorize them now. So I'm going to call this iPads. That way I know where it is in case for some reason the pads need multiple interfaces. They don't in this example, but it makes it easier when you're trying to categorize them. And setIsActive is going to take an input of a boolean, and that's going to be isActive. And we're literally just going to pass that right on through to the spawn pad. But let's make our other functions first. So we're going to make another new function here called iGetCanUsePad. This is going to be a getter function, so it's going to have a single output of can use. And we're also going to put that in the iPads category. And we're just going to duplicate it and iGetLocationName. Location name is going to return a name value that we haven't created yet. But that is going to be in our setup. So this is going to be called location name. And all we're going to be doing is just passing that location name through. That's going to be what determines where our spawn pads are in the world and whether or not they get activated. We have one more here called iGetIsActive boss pad. And this is pretty specific just for the boss pads. This is also going to return a boolean for isActive and be categorized in iPads. But we'll see that more when we get into it. For now, just know that we need these functions. Now inside of our spawn pads, we can go into our class settings and we can implement interfaces, say BPI pads. And now we'll have access to all of those interface events that we just created. So setIsActive is going to do exactly what we said it's going to do. It's going to just take this and pass it on through. Because we're going to be calling these from the game mode, and we didn't want direct references to them in case you want to have some kind of different spawn pad system. Or maybe you want to take spawn pads out entirely. We want to make it easy for you to do that. So this just calls setIsActive from the game mode from a generic actor class reference. iCanUsePad. So canUsePad needs to see if it is active, if it is occupied, and we need one more boolean here. And then it's going to be isBoss. And I created 2 variables there. So we're just going to go ahead and name the other one direction and give it a name parameter. This is going to be instance and exposed along with boss. And we're going to make those setup category. Because we need them for the setup, right? These are going to be what we set up when we drag it out into the world and place it. We're going to say, is it a boss pad, and what direction is this pad on? While we're at it, let's just go ahead and categorize these as debug since we're done with them. Debug, debug. The other actor is technically debug. Active and occupied are just going to be the states, so we're going to call them gameplay. Okay, anyway, we also need isBoss, right? Because we need to check and see if this is a boss pad, because I don't want to use boss pads when I am spawning normal enemies, right? I want bosses to be spawned on boss pads and enemies to be spawned on not boss pads. So if it is not a boss pad, and it is not occupied, and it is active, then we can return whether or not this is true. Okay? So if this is occupied, but it's not a boss pad, and it is active, it's still going to return false because it's occupied, right? Same thing with boss. If it is a boss pad, it's just going to return false because it's a boss pad. So pretty simple there. Get can use pad or get location name is actually just going to be this direction variable we just set up, and we're gonna show you how that works in just a second when we roll these out into the world. And get is active boss pad is just going to say is boss and is active. So if it is a boss pad and it is active, then you guessed it, it's an active boss pad. And we're not going to be using these for a little while until we do the game mode, the game stuff, but until we do the core actor component stuff. But for now, just know that we're going to need this to spawn bosses properly later on. And I'll just call this interface to get it out of the way, and that's pretty much all we're going to do with our spawn pads. So let's go ahead and start dragging those out into the world. So we're going to drag some spawn pads out here. I'm just going to drag one over there. I'm going to drag like 2 or 3 over here. But before I duplicate them, I'm going to add a name. So let me make my details panel a little bit bigger. In our details panel here, we have those 2 setup variables that we just made. I'm going to use cardinal directions in this video. So I'm just going to call this one south. This one's also going to be south. This one over here, if I can click it, is going to be east. I'm going to control D it and call it central and give that one the boss pad. And you did not take the name of east because I duplicated before I hit enter. I'm going to take south over here and put him over here and make him west. And it's going to be totally up to you where you put these things into your world, how you do them. But this is just kind of really quick and basic how we're going to do them. Keep in mind that on some maps, you may need to make sure that these are actually above the ground like this. I think it's fine here that they're like this. We'll find out later. But I know in testing, some other maps with landscapes and stuff needed to be above the ground. Otherwise, they would fall through the map. And if they fall through the map, you're going to have a bad time. So something to keep in mind there. But yeah, that is our spawn pads. Now we just need a place for the pool. And I'm just going to make a cube out here. So I'm going to add a cube. Yeah, I guess like right here is probably fine. And we're just going to move it over here. We're going to make it like 25 or 20 by 20. I guess 20 by 20 is fine. 20 by 20 by 1, it doesn't really matter. You honestly don't even need this anywhere relevant. We just want to see the enemies coming into this pool later on to make sure that they're going to the right place. And we don't want them, again, falling through the map and ending up destroyed because they fell just too far out of the map. We want to give them a place to be and not have to enable and disable gravity every single time, because that is heavier than just leaving them be. Especially if you're using them often, which is the point of pooling, right? So yeah, that is our map setup. More or less, that's what we're going to be using to set up the map. So now let's go ahead and set up our core game objects. So I'm going to make a new folder here called game. And you can do whatever you want. Sometimes it's core for a lot of people. For me, I've gotten into the habit of just labeling it game. I'm going to make a new blueprint class in here of the type game mode based, and we're going to call this GM custom. Because we're going to have to fill out a bunch of information in here and make it the default map. So I need another blueprint here as well, because this is going to be spec for multiplayer, right? So I need the game state. I'm going to use game state base, and I'm going to call this GS custom. I'm just going to open that up so I can save it. And we also need our player, right? Because we need a way to move around in the game. So I'm going to make another new folder here called player. And inside of this player, what I'm actually going to do is I'm going to take the third person blueprint. So I'm going to take this third person player here, and I'm just going to drop them in my player. So I'm going to move him here. I guess I could have copy and pasted him, but I moved him, whatever. Doesn't really matter. I'm going to rename him anyway. And then we're going to take this input and move it into player, because we're going to need a new input. Okay, but we'll worry about that later. For now, we're just going to name this player. And we're going to be making a player controller, so we need a new blueprint class, player controller, called PC custom. You'll probably want to have more descriptive names, but since we're only doing one level here, custom is fine with me. And we're going to make another one here called player state. So another new variable, we're going to search player state. And that is under actor info player state, and we're going to call this PS custom. Okay, so now that we have our player state and our player controller and our player, we can actually go ahead and start setting those up in the game mode. So our game state class is going to be GS custom, our player controller is going to be PC custom, play state is going to be PS custom, our default pawn is going to be the player, BP player, and that's all we actually need to switch here. If you want to do a HUD class, you can. This is not a UI-centric tutorial though, so we're just going to quickly grab that from the player controller later on. Now that we have all that set up, we're going to go into the project settings, and we're going to go into the game mode class and select GM Custom. But since this is the third-person template from Unreal Engine 4, or 5.4, it's going to have the world override as well of third person. So we need to make sure that we're overriding that world as well. That way we have the defaults, or just clearing it. Now when I press play and I walk around in here, I should have my player, and I should still have access to all of the walking around stuff. Okay, great. I think we're at the point now where we're just going to go ahead and make the component, and we're going to build out everything around the component as we make it. Because now we've kind of got our world set up the way that we want it for this little sandbox, and we can go ahead and start working on the component. So I'm going to make a new folder called Components. And inside of that folder, we are going to make a new blueprint class actor component. And we're going to call this AC Wave Manager. Or actually, Wave Game Manager is a bit more accurate. So we'll call it a Wave Game Manager. This is going to live on the game mode. And it's not going to live anywhere else outside of the game mode. So on the game mode, I'm going to say AC Wave Manager. Basically, having it live on the game mode prevents us from having to do a bunch of honestly nonsense in the actor component to make sure that we're running on the server and we have the right authorities and we're not duplicating things. Because having it on the game mode basically just says it already has the authority to do what it needs to do. It's already the only one that exists in the world. So we're going to just run it on the game mode with the game mode's authority. Essentially, you could write all of this inside the game mode if you wanted to. Or you could have split it into two different actor components, which is what I did at first. I had a Wave Game Manager and a Horde Manager, pretty much, and we did it on two separate components. But ultimately, I think it is easier to just do it on one component, easier to understand anyway. Now, a lot of stuff is going to happen inside of this component, okay? A lot of stuff. This is going to handle the Wave Game everything. This is going to handle the game timer. This is going to handle the enemy spawner, all of it. So what becomes important here is what we're going to do on event begin play. And we're just going to take it from play and build everything out. What we're going to do is get all actors of class, or I should say get all actors with tag. And when we get all actors with tag, we're going to get one that says pool locator. We want to make sure, though, here is the only important part, that we really want to make sure that we have that proper tag in the pool locator. So I'm going to just take whatever I typed in the pool locator, because it's probably spelled wrong, knowing me, and I'm going to put it into this, and it was spelled wrong. So, you know, I'm actually just going to take the proper spelling of the words, and I'm just going to paste them in here, and I'm going to paste them in here. Maybe it wasn't spelled wrong. Maybe it's just my eyes. Like, I can barely read, okay? I'm almost blind. Anyway, we're going to get all actors with tag of pool locator. So again, whatever you want to have pool locator, if you already have other actors in your world, just give one of them the tag pool locator and don't even worry about creating pool locator, right? We're going to get actor location. And this is basically just so we don't have to store this actor, because we honestly don't need it. We just need the location. So I'm going to promote that to a variable and call it pool location. Now, staying clean here is going to be important, so we're also going to categorize this as pads. And probably you should give it a comment of what it does later on when we use it, or now. It does what it says it does. It is the location of the pool in the world. That way we don't have to query the world every single time we need this location. This location is static. So we have found whatever the world location is wherever we are playing, and we have set it to a variable so we can use it later. And now we're going to get all actors with interface. Get all actors with interface is basically the same thing, except it checks all of the actors in the world for the ones with an interface. And that's why we do this on begin play, because you'll have a loading screen probably. This will take a second, and that's why we have loading screens. But you'll never have to run this again. So we promote this to a variable, and we call this spawn pads, because we're going to be needing to, like we did all those functions earlier in BPI pads, we're going to be needing to use these, okay, in the wave manager. So I'm going to close out some of these other things as well. We're going to open them as we need them. And it's bothering me that they're open. Anyway, inside of this wave game manager, we're just setting these spawn pads. And this is just an actor reference. It's not directly referencing the spawn pads. And that's all we're going to do on begin play. I'm going to call this something like begin play setup self. And tuck it away. It's done. So you may be wondering, oh, I'm also going to put spawn pads in the pads category as well. Again, I'm not worried about replication or anything like that here, because this is the only source of truth. There's nothing to replicate to. Anyway, we wanted to show that that is not creating dependencies, right? So I'm going to take this wave manager component, and I'm going to right click it, and I'm going to hit the reference viewer. And the reference viewer is really going to show me what it references, and the only thing it is referenced by the game mode, which absolutely has to happen because it has to live somewhere. And it's referencing BPI pads. So it's just referencing a blueprint interface, which is like nothing. If I look at the size map here, the size map is literally nothing. It's just the BPI and itself. I guess BPI can get expensive if you like do too many. Anyway, now that we've done that on event begin play, we actually need to use these pads in some form or another, right? So let's go ahead and build out some of our pads functionality. So I'm going to make a custom event here. And pretty much everything is going to be called internally, just throughout the loop of this actor component. And we're going to call this setup spawn pads. And setup spawn pads is going to need to take in an array of names. And this is where we're going to really start using that BPI. We're going to call this spawn locations. It's weird that it's locations, but I know. I'm going to say is not empty. Because if we ever pass an empty spawn locations into the system, we want to just use all pads. Because something has happened and we did not set up our spawn locations. And, maybe that's by design, right? Maybe we just didn't want to... we want to have like a free play mode where all of the spawn locations are always available. And if you do that, there's actually ways to do this a little more efficiently by basically just saying that all of the spawn pads are always active on begin play. And setting a boolean or something here, like always active spawn pads. Before you even call spawn pads, you would check that. But we're not going to do that here. I just wanted to give you an example. We're going to run a for each loop through true and set up our spawn pads. Because my system is basically always going to be using different spawn pads. That's the way I like it. We're going to drag out of the array element. We're going to say I get location name. And that's that BPI message we made earlier in the spawn pads. So as long as spawn pads implements this interface, which you could run does implement interface and run a branch check. I know that it does, and if it doesn't, I'm going to find out because my game isn't going to work. And we're not going to go so far without testing it that that really matters. So we're going to take our spawn locations. We're going to see if it contains the location name. And if it does contain the location name, then we are going to set it as active. So we don't even need a branch here because we're just going to be using that set is active. So we're going to drag out of the array element one more time. I'm going to press R to route it down so it's a little bit cleaner. And we're going to say set is active. And again, that's that message we made earlier that determines whether or not the spawn pad is going to be active. Because we're going to be querying these spawn pads when we need to spawn an enemy to see which one we can actually use. So set is active to whatever this contains. Again, this is, I think I said this was for when it is empty. This is when it is not empty. Is not empty is true, then we have locations, right, in the array. And we want to make sure that the location of the pad matches that location to be active. And that's pretty much all that happens there. Down here, even easier. So this is, if this is an empty array, so we have not set up our spawn pads, we are just going to literally set is active to true on every single spawn pad in the world. Okay? Every single spawn pad in the world is just going to be true. And if I remember later on, maybe we will do a little something with these spawn pads to make sure that like once we reach a certain wave or something, we can just use all pads or have a method to do that. I think that would actually be beneficial to the system, but for now, we're just going to keep going with the way that the demo has gone. So one more thing needs to happen with spawn pads, because this just sets up the normal spawn pads, but we're going to support bossing. If you're not going to support bossing, you can, again, skip all the bossing steps. But I am, so I want to set up the boss pad. In order to set up the boss pad, I did a little bit different, and it's something you could honestly do with spawn pads if you don't want to have like active or inactive or checks to see if somebody's standing on them and double spawns and stuff like that. This way is slightly more efficient. So what we're going to do is we're going to duplicate this pool location, and we're going to call it boss pad locations. And we're going to make it an array of vectors. The first thing we're going to do is clear this out because we don't want to have any information in here when we start checking to make sure we're getting proper boss pads. Then we're going to take spawn pads. We're going to run a for each again on spawn pads to get is active boss pad. That's that other message we made. So this is always going to run after this. Okay? This is always going to run after setup spawn pads. And spawn pads doesn't ask whether or not it's a boss pad. It just asks, is this the location we want to spawn at? Yes. Okay, we're active. No. Okay, we're not active. So if we want to spawn the boss at center, which is where we set up the center pad, we'll need to make sure that we either pass none in here or we pass center in here, just to make sure that that center boss pad is active. And then when we loop through this, if it is active, then we're going to just add it to this boss locations. So we're going to get location, get actor location, and pass the actor location right in here, because that's all we need to do. That's it. Nice and easy. Basically, just if it's active and it's a boss pad, we get the locations. And this is just a handle if you have like more than one boss pad and you want to have, I don't know, different, I guess locations to where the boss can spawn, and kind of pick one randomly. That's all we're going to be doing from here, is just running it on a random when we get to spawning the boss. Okay, and that actually clears up pads. So what I'm going to do is I'm going to drag all of pads, and I'm just going to condense this, collapse to nodes to say handle setup, something like handle spawn pad setup. That way my blueprint designer over here is not cluttered. I don't like it being cluttered. I have a nice little place for these to be, right? You don't have to do it if you don't want to. That does make navigating a little more difficult, because then I click into this, well, I don't get a new graph, and then I'm like, okay, I gotta click back to my event graph, and then I want to click something else, and then do something else. But this just kind of, I like doing this. It condenses them, makes the graph more manageable. Otherwise, this graph would be huge by the end of this video, right? And you'll see if you watch the episodic version of this series that that is exactly what happened. The graph was huge. Okay, so that was our pads event. Let's go ahead and start working on our timer events. And to work on our timer events, we're going to have to start implementing some blueprint interfaces for multiplayer support. I'm going to go ahead and create the enemies next. That way we can get an enemy, basic enemy, running around in the world. Make a new folder called enemies. And we're going to be using a very simple AI controller to handle these enemies. So I'm going to make a new folder called AI. And we're going to make a new blueprint class of the type character, and we're going to call this BP enemy base, because this is going to be the enemy base class. I'm also going to create a child blueprint of that, and I'm just going to call this BP enemy red. That way I have a child to work with, because we're going to be setting these up pretty much right now. So the enemy red child, I want to just use the skeletal mesh of Manny, and just Manny is fine. But I'm going to be using Manny for all of these enemies, so I don't want them all standing up like this. So we're going to like get our calculations, which I already know is minus 90, minus 90. But we don't want to do that on every single child, right? So we're going to do that on the base class. So even though this enemy base doesn't have anything here in the mesh, if I hit minus 90, and then I come over here and I hit minus 90, and I compile save this base class, this enemy red is now going to be standing where I want it to be. We also need the anim class, so I'm just going to use AVP Manny, and that's going to be fine. We're not going to do pretty much anything else to enemy red. Now, inside of the enemy base class, we're going to need a few blueprint interface events and ways to... Basically, this base enemy class is going to be what handles the enemy pooling logic. So not when it is being told to go to the pool, but where it just needs to go and activating and deactivating itself. That way we don't have to have like a super long graph in here that activates and deactivates an enemy and relies on the exact functions being created in that enemy. So if you want to like move to a different enemy base, you have a different enemy base class you've already imported or bought or made. We'll be able to handle that gracefully this way. But for now, all we really need to know is that there are going to be a few variables inside of the enemy. So we're going to make some variables here. One is going to be isActive, which is going to be a Boolean. We have another one, which is isBoss, which is going to be a Boolean, and it's going to be instance. And we're going to have one more here called health. Health is just going to be a float because we're using a very, very simple health system in here to destroy the enemies. And one more called enemy controller. And that is going to be of the type we're about to create, because we need a way to control this enemies. So I'm going to make a blueprint class. We're going to search AI controller, no underscore, AI controller. And we're going to use that to make AI enemy controller, the AI enemy controller class, and we're going to use that class for this AI enemy controller. Now, you could set this up to be the enemy controller by default, but I'm actually going to pretty much consider this a base class, or probably in my game make an enum on my enemies for enemy type, to basically give them a different type of controller or some other logic there, because you probably don't want them to all run the exact same logic, right? The same behavior tree, the same thing. But to keep this simple, we're just going to have the enemy be possessed by whatever this controller is. So this enemy controller is only going to do one thing. We're going to say on possess. We're not even going to have sensing or anything like that. We're just going to say on possess. And on possess, we're going to run a behavior tree. So we need to go into our artificial intelligence here. So we're going to go to artificial intelligence, and we're going to make a new behavior tree. We're going to call this BT roaming, because all this is going to do is roam. And you'll probably want to make a more advanced AI. That's not really the point of this series. We just want them to be able to move in the world. But I would recommend going over to Ali's videos. I will link them in a card for you. So we're going to hit this new Blackboard button. I guess I should have shown that better. This new Blackboard button up here in the behavior tree. And we're going to call this BB roaming, because that's just the easiest way to get the Blackboard and the behavior tree kind of connected here. And we're going to have one key inside of this, and that is it. And that is going to be random location. I'm going to control A and control copy that because I'm going to need it in a second. And we're going to go back into the behavior tree, and we are going to run a sequence. So just drag out of that and say sequence. Basically, a sequence says we're going to do this first, and then we're going to do this second. Whoops, this second. And this second is going to be move to. And that move to is going to use this Blackboard observe Blackboard value of random location. And it is going to be an acceptable radius of, let's say, 50. We might have to make that a little bit bigger. But basically, the more the acceptable radius is, kind of the smoother this system's going to run. It's not going to run as intensely because they're not trying to get to exactly the perfect location. And now for this first sequence, right, we need a way to get this random location variable and set it. And to do that, we're going to make a new task, and we're just going to call this BTT random in range. I know I called it something different in the other project, but whatever. BTT random in range is going to receive execute AI. We're going to take the controlled pawn. We're going to get actor location. And this is the location of the pawn that whatever is calling this is controlling. And we're going to random reachable. And this AI navigation, get random reachable point in radius. We're going to promote radius to a variable called radius. Make that instance and exposed. That way radius is able to be set from when we put this task in. And then we're going to need to set Blackboard value as vector. And we can honestly promote this key to a variable as well and make it instance and exposed, and that'll be a little bit easier to manage. We're going to set this Blackboard key as that new value, and then we are going to finish our execution. Finish execute AI behavior tree function with success. Always finish. If you don't finish, this is not going to, it's not going to go well. It's never going to get past the task. So we need to drag out now and use our BTT random in range to this AI move to. And now we need to set up this BTT random in range. So the key here, we made it a variable, so it's easy to just select the key instead of copy pasting the exact name. And we'll use random location, and the radius here we'll say is, let's just do 2000 or 2500. Again, bigger is kind of better here. It's not going to be trying to find the optimal location and running it, but it doesn't really matter because this is such a lightweight behavior tree anyway. Really, we just, again, want the enemies moving around in the world. So, our event on possess, I'm going to delay just to make sure that everything is loaded up in the game. And then I'm going to run behavior tree. So you're just going to type run behavior and select that behavior tree we just made. And that's all we're going to do in the AI enemy controller. So on possess, we're just going to delay a second and then run the behavior tree. Because that's just all it really needs to do. Now inside of our enemy base, in our event graph, we need a way to make it basically possess the enemy controller. So I think we actually have the time to build out the enemy here. I wasn't going to, but I think we have the time. And what we're going to do is we're going to go into our interfaces and go into BPI damageable, that one we made earlier, just to see if it was an enemy on the spawn pad. And we're going to go ahead and make our two functions in here. We have one function which is going to be I return to play. And that is going to be in the category of damageable. It's basically to make something return to play once it has left play. We want I remove from play. Just like return to play, this is going to remove it from play. And we want I get is active. Because we want to know if a thing is active before we try to do anything with it. Is active is going to return a boolean of is active. Remove from play is going to have an input of a location because we want to know where the pool location is. So pool location. And return to play is also going to have a location, and that's going to be spawn location. And that's going to be the location of the spawn pad that we want to put this enemy at. And that's all that's going to happen inside of here. Now, inside of our enemy base blueprint, we want to go into the class settings, and we want to say BPI damageable. This is also a good time to check and make sure we are doing all of this in the enemy base, not the enemy red or the child classes. This needs to be in the enemy base. If you've been working in the enemy child class on accident, go ahead and delete everything that's in there because you don't need to do it, and come over here to the enemy base, except for your skeletal mesh, of course. That's the only thing that the child needed. So friendly reminder there. Get is active, pretty simple. Get is active. And these other two, we're going to double click to implement them on the graph, are basically going to be what handles the pooling logic. So we're going to call these from the wave manager component or the game mode when the enemy dies, right? So that way it's being handled properly with the authority. So we need to first get our enemy controller and see is valid. Whoops, not that is valid. We want the operator. Because this is going to determine our next action. If this is valid, then we just need to have it possess this enemy. Okay, if it is valid, we just need to have it possess this enemy. Because it's going to already exist in the world, we just want it to run, right? If not, if we don't have a controller already, we just need to spawn one. And I'm sure there are slightly better ways to do this as well. AI enemy controller is what we're going to spawn. We don't need a transform on it. And we're going to set that to enemy controller. So I guess we will just make this the AI enemy controller reference. We gave it a shot. It didn't work out. I didn't think it would, but I was hopeful. Something about making, not accepting the parent class reference. So we're going to select our class here, and that is going to be AI enemy controller. We're not getting away without having hard references to these in the character that it's possessing anyway. Which is why we're doing this inside of the character it's possessing and not a bunch of other stuff. We're going to set that to enemy controller, and then we're just going to have enemy controller possess, just like we were doing. So the only difference is that we made this the AI enemy controller. We're going to compile and save that. Now, when this happens, this is again going to happen when we're removing an enemy from the pool and making them play. By the way, make sure you're not dragging off of this pin. If you drag off of this pin and for some reason the enemy controller was valid, you're going to have a bad time because it's going to be using now an invalid pin because this never ran. So that's why we make sure we get a clean reference to the pin and punch it in here. But yeah, we're going to do two things here to basically stop this actor from taking up resources. We're going to set it in hidden in game and set enable actor enable collision to no collision. And this is basically the brunt of getting an enemy to not take up resources while it is in the pool. Making sure that we unpossess it, of course, and set it hidden in game and disable collisions. I found that everything else kind of gets messy and doesn't really help with resources very much. But if you want to add more stuff in here, this would be the time to do so. We're going to set health to 100, because again, we're just using a simple, cheesy health system for this. And then we are going to set is active to true. By the way, health and is active do need to be replicated. I totally forgot to mention that earlier. They're just going to be replicated. And then we need to set actor location. And that new location is going to be coming from this pool location. So we're going to do that. And we're going to make sure we teleport. And that's all that's going to happen when the enemy is returning to play. When we remove them from play, we're basically going to do the same thing. We're going to check and see if this is a valid controller. Because if for whatever reason it's no longer a valid controller, then we don't need to unpossess it. But if it is, then we need to unpossess. So unpossess. That way the controller is not running in the background. We don't want that. That's a lot of resources. And then we're basically going to do the exact same thing here. All of this stuff in the same order as well. Just going to be hidden instead of not hidden. It's going to be not collision instead of collision. It's going to be 0 on the health instead of 100. It's going to be not active. And the pool location is just going to be the location that we're going to. Which I totally, well, maybe you caught that, maybe you didn't. I totally did these in the wrong order. I did remove from play where return from play goes. And so remove from play is this bottom one where we unpossess. You were probably thinking, what the heck is this guy doing? Remove from play is this bottom one where we unpossess, and return to play is this top one where we possess, obviously, right? Maybe you caught that, maybe you didn't. But that is what's going to happen here. All right, we're keeping this very lightweight and simple. If you want the enemies to do more things, or if your enemies do more things and you need to add that logic in, you can add it in your enemy class and not the component, which was part of the reason for this. I don't want to have to fiddle with this component every time I need to do something or move it into a different game. We're just going to call this interface events. And now our enemies should be more or less ready to be spawned into the world. Actually, to make sure this is working, let's go ahead and just do this on event begin play in the actor component, right? Because we already have gotten everything we need. So we will just say we want to delay and then start running our debug logic here, which is just going to be set up spawn pads, and spawn pads we are going to make east, and we are going to spawn actor from class. We'll just do this like 30 times, so we'll say for loop. We'll do this 25 times, and we'll just say spawn actor at the location of the spawn pad, so we'll get spawn pads. We know there should only be one, but we'll just say random. Get actor location. Split the transform, plug it into the transform, and select the enemy base red. And basically we're just going to spawn a bunch of these enemies in. Hopefully at east. And once we spawn the enemy red in, we actually do need to make sure that we return them to play. And we're going to use this actor location for return to play as well. We could just spawn them at, let's just spawn them at the pool location, and then return them to play. That sounds fine. Because we're going to be doing things, that's the wrong return to play, by the way. We want the return to play message, because we're not going to be spawning enemies this way. And use that as the pool location. That way they're spawning in at the pool and then moving over here. And then, yeah, that'll be fine. We'll see how that works. Again, just make sure you're calling return to play, otherwise they're not gonna know what to do. Okay, and they're all returning to play. And now, something I've noticed with my engine is that for some reason the enemies just do this on the server player, which is really weird, because if I go to net mode, I play as listen server, and I play with 2 players in a standalone. So we'll just do it in a new editor window. On my server here, the enemies, I guess because of replication or something, are all not animating. And then on my client, and this is the client over here, they are animating, which is like totally weird. And that's something to do with the enemy base, the character movement in the enemy base class. We want to come down here and we want to search for the acceleration for paths setting. So in your nav movement, it's use acceleration for paths. And for some reason, using acceleration for paths is what lets them be animated on the server player. So yeah, and movement is replicated by default, so as long as you're not doing really complex movement that isn't handled internally by the engine, this will replicate just fine. If you're doing more complex stuff, then you know you're going to have to set that up in your character. But that's not really the point of this video. Yeah, so we have our enemies running around in the world now. Right? Our enemies are running around in the world. We have no way to destroy them, but they're running around in the world. So now back inside of our wave game actor component, I don't need any of this stuff, so we're going to delete it. And we just wanted to get that tested out. And we're going to carry on with building this out so it doesn't take us all day, hopefully. And we're going to do that by making the timers. So we have 2 timers. We have a start spawn timer, which is going to set timer by event. And that is going to be a custom event called run spawn timer. And then we're going to have another one here, which is called start countdown timer and run countdown timer. And that is going to be set timer by event again, with the event being run countdown timer. So basically, we're just going to promote these timer handles to variables in case we ever need to use them. This is going to be countdown timer handle. And this one up here is going to be called spawn timer handle. These are going to have their own category of timer. And we're going to use these to basically pause these timers when needed. I think countdown timer is easier, so we're just going to go with that one first. This is going to be looping, and the time here is going to be 1 second. We want this to tick every second for however long we have in between our waves, right? That's basically what this is doing, is giving us time between the waves to do whatever it is we need to do. So we need a variable to handle that, and that is going to be called time elapsed. And that is going to be an integer. And it is going to be a single integer that we're going to put right here and clear before we do anything. And we're also going to make that in the category of timer, because that's what it is. It's the integer for this timer that basically controls how many loops this has gone through. So the first thing we're going to do then on run countdown timer is increment the time elapsed, because we have elapsed 1 more second, and we want to increase the time elapsed. Out of that time elapsed, we're going to need another integer variable. This is going to be called time between waves. And I'm going to put this in the category of setup, because this is going to be what we use to set up the game, right? This is our kind of configuration for whatever game we're playing. So we're going to take our time between waves, and we're going to subtract the time elapsed to basically get a countdown timer running of time remaining. And that time remaining is going to go down by 1 every single time that we do this. So by default, I just want to set time between waves to 5 seconds. It doesn't really matter too much. And then we need a way to basically control the UI for all of the different multiplayer players, and we're going to do that through the game state. So we're going to get the game state here. Now I wanted this system, again, to be as modular as possible. I don't want to have to cast to game state custom and make sure that I'm getting the proper game state. I could be replacing any project with this, right? I could be dropping this into something that has, for whatever reason, multiple different game states that need to use it, or like just a game state called the game name, so game state wave game. Instead of game state custom, I don't want to have to go in here and change all that, I'll be honest with you. I just want to add the BPI onto whatever it is that I'm basically trying to use this component on. And that basically gives me all the functions and everything I need, kind of right out of the box, easy to set up. So we're going to make a new blueprint interface again, and we're going to call this one BPI spawn interface. And spawn interface is going to communicate with a game state, or I suppose you could make it communicate with a game mode as well. The first thing we're going to say is I set countdown time remaining. And we're going to need a couple more functions in here. This one's going to take an input of an integer of time remaining. And I'm going to put it in the category of spawn. I guess spawn is fine. Spawn interface, whatever you want, just to give it a little bit of just to give it a little bit better layout inside of your blueprints. And we're going to duplicate this, and we're going to say I set total enemies. We're going to duplicate it again. We're going to say I set new current wave. This is going to be current wave. This is going to be total enemies. Okay. And we're going to need one more in here. And this one's not going to have an input. And this is going to be I enemy killed. And it's not going to need an input of an integer. It does need an input. It needs an input of boss. That's right. Because we need to know if it was a boss killed or not a boss killed in order to handle scoring. But yeah, that is just going to be in the category of spawn as well. And we should be good to go and implement that. Again, this is just so that any game state that I use this on, I can just implement this and write these functions real quick, or just copy them over from my other project, right? This project that we're building today. So inside of my game state custom, we're going to go to class settings. We're going to open the full blueprint editor. And we're going to go to class settings, and we're going to go to the implemented interfaces and say BPI, again, spawn interface, the one we just made. Now, this is all going to be pretty simple, but you got to follow along, okay? Because we're going to be doing some stuff here. So, we're going to use this I enemy killed to see if it was a boss. We need a way to keep track of score. I'm also going to take this I new current wave, and I'm going to promote current wave to a variable. That way we have an integer here to work with. And I'm not going to categorize these things. You probably, I will categorize them. But that way we have an integer to work with, and I'm just going to call this wave. And this is going to be on the category of gameplay. Just so that if I add stuff in later on, I don't have to worry about categorizing it. This is going to be replicated. It's actually going to be rep notify, which is going to give us this little notify function. That way when wave is changed, we can run a notification event to everyone who is listening that the wave has changed. Okay, I set total enemies is basically going to do the same thing. We're going to promote total enemies to a variable called total enemies, and then we're going to promote that to a variable again, and that one's going to be called enemies remaining. Both of these are going to go into gameplay, and both of them are going to be rep notify. Cue that up. I set countdown time remaining. Again, same thing. Promote time remaining to a variable. That's going to be time remaining. That is going to be in the category of gameplay, and that is going to be in rep notify. You can categorize these however you want. But we do need two more variables here, so we're going to just go ahead and make those right now. Or we need one more variable, I should say. Yeah, we need one more variable here called score, so I'm just going to duplicate time remaining and call it score. It's going to give me this error message, and it's not going to be rep notify anymore. And now we're going to make it rep notify, and now it's going to be rep notify. So with this score value, basically we want to keep track of the score based on whether or not this is a boss. And this is going to be very simple score logic. So what we're going to do here is we're going to take wave. So we're going to get wave as well, and we're going to say wave plus score. So just add the current wave to the score. So if it's wave 20, then a kill is worth 20 points. to set score with notify and take our enemies remaining, and we're not going to decrement here. If you watched our other tutorial series, you saw that we decremented, and that was actually a problem. I need to go in and fix that because we cannot decrement. We need to set enemies remaining to -1. Decrement doesn't give off the notify, and then it makes you put redundant event callers that can ultimately lead to bugs. So we're just going to say enemies remaining -1 is going to be set with notify to enemies remaining. Okay? Because increment again doesn't set with notify. You would have to like set it again after this, which is then why even use it. Now, on the top here, we're basically going to be doing the same thing with score, except we're going to first multiply wave by 5. So we're going to say wave times 5 plus score is going to equal new score. Okay? Wave plus times 5 plus score. Again, this was just very simple scoring logic. It doesn't matter. It's whatever you want to do here. You're probably going to want to do something different for your game, and maybe even have more factors in here that actually influence this instead of just making it dead simple like this, right? And we're just going to set enemies remaining to 0 because I don't want to handle after bossing. Once the boss is dead, the wave is over. That's how we're setting this system up if you have a boss. So we're just going to set enemies remaining to 0. That way that gets updated. Whoops. So now we need to fill out all of these on-rep events, and these on-rep events are basically all going to do the exact same thing. I know this feels redundant, but these are just going to call event dispatchers. So we're going to call onWaveChanged with a new parameter of an integer of new wave. And so that's an event dispatcher. You can come in here in the upper right and add an input argument. And then we're going to call that onRepWave and use wave as the notify. So basically, when the rep notify happens, this triggers on everything that exists in the world pretty much to say, hey, wave has updated, do whatever it is you need to do with this binding to make wave update. And we're going to be binding this in UI, that way we don't have to run the UI as frequently. And it's really just going to be a debug UI anyway, but this is where you would put your variables, and you would probably run some kind of other logic in here as well, but I don't need anything like that for this example game state. Basically, this is just, again, framework for getting stuff displayed properly and making sure that it is working properly. So yeah, we're just going to make an event dispatch for all of these. So on score changed, on time changed, and on enemies changed. And we'll just make it on enemies changed. That way we can call this from total and enemies remaining. So on enemies changed will be the only one that takes in 2 float, and one will be total. The other one will be remaining. And we'll just call that when we call these. Even though there may be a bit of redundancy once when we call them, I think this will be fine. In my example, I made 2 separate event callers for them. Which you could also totally do. It's fine if you want to make 2 different event callers, if that's simpler. Whoops, not time remaining. Enemies remaining. If I can put things in the correct spot today. And we're just going to fill out enemies remaining and total enemies in there. And compile, save that. And on score is just going to do the same thing. We're just going to call to get score, and we're going to say on score change. We want to call that. We want to make sure that on score change has an input of a float or of an integer of score. Or you could use the built-in scoring system if you wanted. I don't want to. I don't really care too much for built-in systems like that most of the time. On score changed, and just really making sure we filled all of these out properly. And time remaining is the only one that didn't. And on time change needs new time. New time remaining, and on time change is going to call new time remaining with time remaining. Okay. So I know that was kind of a long tangent there where we went off, but we're going to need most of these event callers now inside of the actor component when we run the countdown timer. So when we run this countdown timer, the first thing we're going to do is take the game state and say I set the countdown timer remaining message. That way the game state knows what that is. That can go ahead and update on the UI as quickly as possible. Then we need time elapsed again and time between waves, and we need to see if time elapsed is greater than or equal to the time between waves. And if that is greater than or equal to the time between waves, we are going to take the countdown timer handle, sorry, I just sneezed, and clear and invalidate it because we no longer need this countdown timer handle, okay? We no longer need it. It's out of here. It's done. We're good. Now, if we clear and invalidate this countdown timer handle, then we need to get our game state again, because we actually need to update our game state with our new values. So that is I set new current wave. And again, this is not coming off of the actual wave. When we set wave inside of this component at the end of the wave. So we're going to call this wave, and we're going to put it in a category called management. We're actually setting the wave before we run this timer at all, because we need to, during this timer, be spawning and despawning enemies, figuring out what we're going to be doing in the next wave, all that good stuff. We don't want to do that all at once or outside of the wave, or during the wave, I should say, because then there's probably going to be frame droppage with all the enemies running around. We want to kind of separate this. It's like almost definitely going to be frame droppage. So we also need to set total enemies. When you have a lot of movement components running around at the same time, it's just, that's what it does, it drops frames. And then we're going to need a custom event, because that's going to be start next wave. And we're basically going to call start next wave. And we'll run start next wave in just a minute. Oh, okay. But we need to go ahead and get our structure for our spawner details set up now, because we're going to be using a value out of that to set total enemies. Current wave is standalone because current wave is ultimately what determines what the structure we're about to make gets filled out with. So I'm going to make another new folder here called data. And we're only going to have two things in here. We're going to have a structure and its data table. Struct is going to be s_spawner details. Name it whatever you want. It's just a structure of spawner details. This is going to be a pretty big structure. So we're going to have actor classes in here as the first item. Actor soft class references. And we want soft class references because we don't want any dependencies from this component to be things that impact us in our gameplay. And we also don't want to have to load up every single actor in this array on start, because this is going to be an array of actors, because there might be enemies that we only use once in here or never even use in here. We don't want that to bog down the game either. And this is also just easier to basically let me drop it on any other game or use a different enemy base entirely to manage my enemies. So yeah, this is going to be called enemy classes. And again, that's going to be actor soft class references. Okay, actor soft class references. Now we need a few numbers in here to basically make this system work. We need a single integer called total enemies. And again, this is for this wave, so total enemies for this wave. We want to know if we're using weights now. You don't necessarily need this boolean here. Whoops. You don't necessarily need this boolean here because you could check the next value we're going to create, which is weights, and see if weights is empty, or weights is going to be an array of floats. So if weights is empty, then obviously you're not using weights. So you don't really need this use weights boolean. I think it just kind of helps visualize what we're doing here. And these weights are going to be mapped directly to the enemy classes. So when you put an enemy class in here as a value, so we put an enemy red in here as a value, and then maybe we put an enemy black in here as a value. I'll just use base. Then our weights are going to be for the enemy red and then for the enemy black, respectively. So 0 is going to be mapped to 0, 1 is going to be mapped to 1. Why don't we use a map here? Because I don't like how a map looks when we pull it out. The map does things we don't need it to do. We need array things when we're using these enemy classes. And if you were to just make a map of actor to float here for weights, it's like, what's the point? Because we already have the actor references, so you're just working harder. Next, we need a single float for spawn interval. I probably spelled interval wrong. This is going to be how frequently the enemies spawn. We need another integer here for max alive. This is kind of a safety value. Basically, if our max alive is 15 and our total enemies is 20, we're only going to allow 15 enemies to be alive at a time. And once you've killed one enemy, one more enemy is going to spawn until the total enemies, unless we allow overspawn. And allow overspawn is going to be a boolean. You don't have to make this if you don't want to, but allow overspawn is going to say, okay, we have 5 enemies in total remaining, but our maximum alive is 10. We are going to spawn up to 10 enemies, up to the max alive, no matter how many enemies are remaining or pooled for this. We're just going to keep spawning them because we want to overspawn the enemies. And when all of the enemies for the wave, the total enemies killed, has reached this number, we're going to end the wave and tell all of the extra enemies to go away. So that's what overspawn is going to do. It probably sounds more complicated than it is. It's really not complicated, though. We're going to have boss wave. Again, if you're not using bosses, this is something you don't need to worry about. Is this a boss wave? We're going to have only boss. And that is, if you only want to spawn the boss, you'll select only boss. If you want to spawn the boss with minions, then you'll select no. Boss class. This is important if you're using bosses. This is also going to be an actor. Class. Soft class reference, so that's going to be the boss that we're going to spawn for this wave. If you're multi-bossing, you'll probably want an array. I'm not supporting multi-bossing. And the last thing we're going to do is active paths, and that's going to be an array of names, and that's just the spawn paths that we set up earlier, basically saying which directions the enemies are going to be allowed to spawn in for this wave. But no, if you're not doing bossing at all, a lot of this can be just ignored. Allow overspawn can just be ignored. I wanted to have some features in here for you. I know we all use these components for different things. I might not even use bossing in my project, but at least if I want to use bossing at some point, I'll have the ability to use bossing. Same thing with overspawn. I'm never going to use allow overspawn, but I think it's nice to have it. So something to keep in mind while you're following along here is that, you know, we're lucky we're even adding boss supporting at all, because I don't think it's really required for a minimalistic framework here. But if you want to allow overspawn or multiple boss classes for a wave, then you'll just have to make it an array, kind of set it up like enemy classes is, and branch out on your own from there. This is just a kind of almost minimalist framework. It would be minimalist if I like ignored bossing and overspawning and just had this stuff up here and not even use weights. Just weights is fine. But I wanted this to be at least a little bit flexible for us in the future. Anyway, now that we have this structure for the spawner details, we're going to go into the wave game manager, and we're going to add that as a variable in management, and that is going to be spawner details, and that is going to be of the type, you guessed, struct s underscore spawner details. Okay, compile, save that a few times. It's going to throw a fit. And then we're just going to break spawner details open, and we're going to use total enemies from that for the iSet total enemies. Even though this isn't set up yet, we will be setting it up in the future. So don't worry too much about that. Okay, and we're going to put this start next wave function up here. So we don't need it right now. And this is going to be the countdown timer. Countdown timer, that's what this is going to be. This is done. Let's get it out of the way. We're going to collapse these two together when we're done with the timers. Now to our spawn timer handle. So our spawn timer is going to be totally different in how it works. So the first thing we're going to do is grab our spawner details. We're going to break our spawner details open, and we're going to use the spawn interval for this wave. And we're going to make sure that is looping. I made sure that one was looping too, right? Yeah. We're going to make sure that is looping. And then we're going to run the timer. So when we run this timer, we're actually going to need to do quite a few things, because we need to handle basically spawning the enemy into the world. That's what this timer is for. So every spawn interval of 1 second or half a second or a quarter second, we're going to try to spawn another enemy in the world. So we need our spawner details here because we're going to need some information out of that. And what we need to see is if our max alive is less than or equal to another number. Okay, another number. And that number is going to be in management. It's also going to be an integer, and it's going to be called active enemies, because we need a way to track the active enemies in the game. So we're going to see if that is, if active enemies is greater than or equal to max alive. It shouldn't be greater than max alive. But if for some reason it is greater than max alive or it is equal to max alive, then we need to stop this timer. because we do not want this timer to continue to tick. We don't want to destroy it, but we don't want to let it tick either. So we're going to pause timer by handle, and we're going to print ourselves a little string here that just says max enemies or something like that. That way we know what's going on. Our timer has paused because we hit the max alive, and we can't spawn any more enemies. And once an enemy dies, we'll unpause this timer if it's valid. So that's something to keep in mind as well. All right, now we need a function to get where we want an enemy to spawn at. So we're going to be creating our first function here. Now this function really isn't too bad. I just made it a function because I like having local variables. It's easier to manage them inside of a function. So we're going to say get enemy spawn location. And get enemy spawn location is going to take spawn pads. We're going to run it through a for each loop. And we're going to get I can use pad. So I can use pad. And if we can use the pad, we're going to do pretty much just like we did with the boss pads earlier. We're going to get actor location. I'm going to promote it to a local variable called local locks. And that local locks is actually going to need to be an array. Because we're going to be storing multiple locations in here. Basically, every active spawn pad's location. Now, you could shorten this and just say for each with break. When you find a pad, then use it. But I thought that looked a little cheesy when I was doing it, because basically they would just get the same pad. And as soon as an enemy would walk off the pad, which happens in like before the spawner can even tick again, the pad would be clear, and the next enemy would get on the same pad, same pad, same pad, same pad. And it was like, okay, well, that's not very diverse, right? I didn't think it looked very good. So we're going to run a branch down here. We need to see if local locations is empty. And if it is empty, we need to return some kind of failure. So we're going to add a return node. And I'm going to duplicate that because we're also going to return on false. You could use the selector here. And we're just going to get a random array item, and we're going to use that as the out. So this is the spawn lock. And then we're going to need to add a boolean here of succeeded. Or I should say lock failed. And we're just going to set lock failed to true on the true return because we have an empty array here. So no pads were usable, and that's a problem. We need to return something special. You could just say if equals 0, 0, 0, then nothing returned, but I don't see any point in doing that. You might end up with a pad at 0, 0, 0, just on a one-off, I guess, and I just don't want to have to deal with that later on when I inevitably do it to myself because I said I wouldn't do it to myself. Okay? I know I'm a little bit weird, but I know if I do this and I say is equal to 0 and I just say equals 0, I'm going to end up screwing myself and putting a spawn pad at 0 at some point in the future and not know what's happening, and it's going to take me hours and hours to debug it. So on this location failed, I'm going to branch. Because if this location failed, I need to know about it. So I'm going to make another print string here. And I'm going to make this say something like location failed. We'll try again on next spawn tick. Because this isn't going to pause the timer or anything. This is just going to say, okay, well, try again. And in whatever this spawn interval is, 1 second, it's going to try again. And then if it still fails, it's going to try again, try again, try again. So we could probably do with some escalatory logic here to make sure that when we try again 4 or 5 times in a row, we pause the timer and query the pad, see what's going on. But I've never had an issue with this, so I think it'll be fine. And then we need to actually run another function here, and that's going to be called handle enemy spawn, because it takes in local variables, again, that I want to be able to control. So we're going to make another function called handle enemy spawn. And handle enemy spawn cannot be pure. Get enemy location could probably be pure. Handle enemy spawn cannot. And handle enemy spawn absolutely must take in a location of at location. And we're going to build that out in just a second once we finish this timer. Okay? So handle enemy spawn is just going to take in that location, and it's going to basically handle the enemy spawning into the world. Then we're going to take our active enemies, and we are going to increment that. Because this is not rep notify, we don't have to worry about adding the +1. And we also need an enemies spawned. So we're going to take active enemies and say enemies spawned. which is slightly different from active enemies, right? It's not how many active enemies are active in the world, it's how many enemies we have spawned into the world. So we'll need a new variable for that. That is separate, otherwise we'll get in trouble. And then we need to check and see if our spawner details again, if our spawner details again, we have now spawned greater than or equal to the total enemies, and allow overspawn is not true. So I guess I said again, but it's not. Again, this is the first time we're checking total enemies and the only time. And we want to make sure allow overspawn is not true before we clear this timer. So basically, if our enemy spawned is now greater than or equal to the total amount of enemies for the wave, and allow overspawn is not true, so we are not allowing overspawn, we're going to stop this timer handle. We're going to clear and invalidate it this time. So we're going to take the spawn timer handle again, and we're going to clear and invalidate the timer by handle. That way we no longer have a timer. It's not going to try to resume itself. Even if it is paused at this point, because it comes back around and we have our max alive, even if it is paused at this point, if we allow overspawn, then this is not going to happen. The timer handle is still going to be valid, and when we kill the enemy and loop through everything that happens with the enemy, it's going to basically say, okay, this is going to get unpaused until we have another max alive situation where it gets paused, and it only gets destroyed at the end of the wave. Okay, so that is our timer for the spawn system. We just have to build out that function, which we're going to do in just a second. So this is going to be run the spawn timer and handle checking enemies. I can't see that at all. It probably is spelled terribly, and yeah, broken up. I'll fix it later. We're going to collapse these to timer events. Okay, don't take it. We're going to collapse this to timer events. That way it's out of the way, and we're going to put it up here with the timer. So now we have timer events, which has all of the timer events, and we have spawn pads, which has spawn pad events. Okay, now handle enemy spawn location is what we need to build next, because we're going to be making some maps here that are really important later on when we calculate basically how many enemies we're going to need for the wave and what enemies we're going to roll for the wave before we actually pre-spawn enemies in and start doing all that good stuff. And it's going to look a lot more complicated than it actually is. And what we're going to use here is we're actually going to be using maps now. So we need to take in our gameplay category and make a few, our management category, and make a few maps. So we're going to add a new variable here. I'm just going to do this the hard way. And we're going to say enemies for wave. Enemies for wave is going to be a map, okay, of actor soft class references to integers. And again, that is going to be in management. Enemies for wave is going to be what determines how many enemies we need for this wave. We have another one here called enemies to spawn. And enemies to spawn will basically take the enemies for wave and manipulate that along with our enemy pool to determine how many more enemies we need before the wave starts if we don't have enough enemies spawned in our pool, or we don't think we'll have enough enemies spawned in our pool. Okay? So we're going to get keys out of that, and keys just gets the directory item out of a map, so it gets all of these actors in an array. And we're going to say random. And we're going to promote that to a local variable and call that L rolled enemy. This is not to be confused with the weights and rolling logic that actually determines this entire map. This is just getting a random unit out of the map, because we've already determined every single enemy that is going to appear in this wave. We just want to get one out. We're going to say is valid soft class reference. If it is a valid soft class reference, then we can continue on. If it is not a valid soft class reference, that's kind of a problem, and we need to make sure that we are setting it to a valid soft class reference. So we're going to come out of here on the false and set that by grabbing our spawner details, breaking it open, and getting a random enemy classes. Again, this should not be happening. You might want to print a string here if this is happening and saying, hey, what happened? Because this isn't going to, this might overspawn certain enemies or underspawn certain enemies just by grabbing a random out of here. Because we've already, again, determined how many enemies for the wave. So each enemy type and how many of that type for the wave that we want to spawn. So if this is rolling, it's kind of a problem, but I don't want it to be a game-breaking problem, which is why we're just going to get a random enemy class. That way we have a little bit of fallback room here in case it does break. And now we're going to need to get an enemy from a pool. And we're going to need our enemy pool, and we're going to need to make another function in here. I know I have a lot of nested functions in here. This function is going to be arguably one of the most important functions in the game, though. So get enemy from pool. Get enemy from pool is going to need to take in a pool of live actors. And don't get confused here. This is live object class actors. These actors are already spawned into the game. We're going to call this in enemy pool. And we need one single soft actor. And this is just basically the name of the enemy we've spawned. So enrolled enemies. This is basically just the name of the enemy we spawned. So what we're going to do is we're going to loop through this pool to see if this enemy exists as an actor that has already spawned. And if it does not exist as an actor that has already spawned, we're going to spawn it and handle that gracefully. If it does exist, we're going to get that actor out of this enemy pool and say, hey, it's time for you to get back in the game. So first, again, we want to check, is this a valid soft class reference? Because if it's not, we are in trouble if we try to use it, right? If we try to use it. So I'm also going to get in enemy pool. And we're going to run this false logic first, which is going to run a for each loop on this whole enemy pool. The whole enemy pool, we're going to run a for each loop. And we're just going to say get is active. Remember, that's that BPI message that we made. Get is active, which is not what we wanted. I get is active from the damageable, which I don't know. Okay, I see what happened. I just said active. I didn't say get. Oh, we want to I get is active from the BPI damageable, and then branch, and then if that is false, if they are not active, we need a local pool. So I'm going to promote this to a local variable called lPool. That way I don't have to make it again. And we're just going to take lPool, and we are going to add on false. So any inactive enemy in our game gets added right into this local pool. And then we're just going to pull something out of this local pool if it is not empty. If it is empty, that is kind of also a problem. So we're going to say is empty. Right, that is also kind of a problem because we don't want this to be empty. So we're going to branch. If that's false, we can go ahead and return. We're going to add our first return node. And that return node is just going to take local pool and get a random item out of it. Because we don't know what enemy has been selected for spawning in. We're just grabbing an enemy that already exists in the pool and saying, okay, you're just going to deal with this enemy. Right? You're just going to deal with this enemy because you don't have any way for me to figure out what enemy I'm searching for. So I'm just searching for an enemy that's not active and giving you one at random. You could even do a for each with break here, like we do up top, and only get one out of this if you wanted to. But I wanted to have, I guess, a little bit more robust of a fallback. I don't know, I'm kind of weird about some stuff. Now, if that is true, we need another branch because this is empty. That's a problem. We have no enemies in the pool that will work, and we have already decided that we want to spawn an enemy here. So we need to say is empty on the enemy classes array itself from our spawner details. This is our source of truth. If our source of truth is empty, we absolutely need to some kind of message and probably a breakpoint to say that we have totally failed at life and we need to do better in the future. Because this would be basically a huge error. We wouldn't be able to play the game without enemy classes being set up somehow inside of this spawner details. Like right now, if we try to play the game, we're going to get this failure message. If that is not true, so if that is false, then we can get a random item out of here because we know that there are things in here. And we don't know what we want. We just know that we want something and we want it right now. And we're going to load class asset blocking, which is how you load up a soft class reference. There are slightly better ways to do this, but we're going to keep it simple and just do this. And we're going to cast to actor class. And that's going to get us the actor class reference because load asset blocking gives us an object. And we want the actor of that object, which is ultimately our enemy's base class, right? So when we have that, we are going to spawn actor from class. We're going to split this. That's not what I wanted. We're going to split this. Yes, get it out of here. Split this transform and spawn them at the pool because we don't want to spawn them in the world without setting them up first. They're not going to have the controller. They're not going to have health. They're not going to be in the right location. And then we need our actual enemy pool. So what I'm going to do is I'm going to take this local pool. I'm going to promote it to an actual variable. And we're going to call this enemy pool. And then I'm going to delete it from here. We're going to set that in the category of management. And we're going to add this enemy as soon as we spawn it to the enemy pool. Now we could have made a call function or something to not have to do this, but we only have to do this like twice in the entire graph. So I think it's fine. And then we're going to return. We're going to add a return node of the enemy that we just spawned. So this out enemy. Okay, hopefully that makes sense. That is all happening on the false branch. Basically, we're looping through the enemy pool that we have given this function to say what enemies are active. If an enemy is not active, add it to the pool. If the pool is empty, then we need to spawn a random enemy from our spawner details because we still don't know what enemy class we're doing here. So we're just going to get a random one and load it into the game and spawn it and return it. If that is false, we are going to just return this random here. Because we have found an enemy, and we're just going to return empty on that one. Because we have found an enemy who that is inactive, and we don't know what enemy we want, so it doesn't matter what enemy we pick. Okay? So that's a totally valid way to do this. But generally, right, we're going to know that we have the enemy that we want. So we're also going to do a for each on this enemy pool. But this time, we're just going to do a for each with break, because I just want to get the first enemy in the pool and stop running logic, because this is what's going to run 90% of the time. This should run 100% of the time if you have everything set up right, but this was going to run. So we're going to iGet is active again. So iGet is active from the BPI damageable through the loop body. When we find an enemy that is not active and equals our condition, so and equals our condition, then we are going to set a local variable for this enemy found. So we're going to promote that to a local variable called L found. And we are going to return that to the break. That way we stop this function once we found an enemy that is not active. So we need not on here because the other value we're going to be checking for is true. So if an enemy is not active and the get enrolled enemy class, and that is the input of this function, is equal to the get class of this actor that we are looping through in the pool, then we have found our mark, and we can go ahead and return it. Okay? We found our enemy that we want to pull out of the pool, because the class is the same and it is not active. Okay, hopefully that makes sense. Just going to drag this up out of the way a little bit so I have some space. And then off of the completed now, we need to check and see if local found is valid. Because if local found never gets set here, it's not going to be valid. And that's going to determine our next action, if this is valid or not. If it is not valid, I want to take my enrolled enemy and I want to load class asset blocking because I need this asset to be available like right now. Not in a few frames or right now. And we're going to cast to actor class and do the same thing we did down here. We're going to spawn actor from class. We're going to split the transform to the pool location. We're going to add it to the enemy pool. So we're going to get enemy pool. We're going to add it in. And then we're just going to return it like we did on the false. This time, the only difference is we know what enemy class we want to spawn, so we don't have to look through the spawner details, enemy classes, and get a random one. Okay, that's the only real difference. And then obviously on our true here, this local found is valid. We're just going to go ahead and return it because that's it. We found our valid enemy. And ideally, this is what's going to be running most of the time. We just want to be able to handle any events where we did not have enough actors spawned. And this is different from a lot of spawner systems you're going to see. A lot of them will tell you to run a for loop on begin play and do that 200 times. Whoops, not that. And do that 200 times, right? And spawn all of your actors in 200 times. I'm not going to do that because I don't I don't like the way that's good for ammo, right? That's good for objects that you know you're just going to have a pool of objects. But I don't know with this wave manager component how you're going to be running your game. And you might have instances where you want to have just extra enemy. You don't want to have to wait for enemies to die in order to grab them again. Like if I don't know how many enemies I'm going to be spawning in, so I have my enemies to spawn, right? And I have my enemies for wave, and I have my enemy pool. Maybe I need 5 goblins for the wave, but I only actually want to spawn 2 or 3 of those, because if I spawn all 5 goblins, there's no point, because I also have 7 ghouls and 8 zombies, or something like that. And the goblins is really rare. It's not going to spawn often. Maybe I don't want to pool all of those when I spawn in between the waves, even though that's definitely how I'm going to do it. I think that's the better way to do it. But if there's ever an event where one is not pooled or something, we don't have to wait for the game to progress. So we don't have to wait for that enemy to die. We can just go ahead and spawn another one in. That's not going to hurt our pool. Our pool's still going to have maximums. And this functionality here is only running when we have decided we want an enemy to come out of the pool, right? To be on the screen right now. Right now, we want this enemy in the game, running around. Not 10 minutes from now, not an hour from now, or right now. Because if we don't do it right now, then we have to find a way to handle basically this entire function crashing and not working the way it is intended to work. And I don't want to have to do that. So, by the way, that's not going to be that. I just kind of plugging stuff in here while I'm mouthing off. So hopefully that all makes sense to you, why we are doing the things that we are doing here. So here we're going to take the enemy pool, and we're going to plug in our just straight up enemy pool. We're also going to take in this local rolled enemy, not this one. Otherwise, you're going to get errors when this is true, and this should be true. And then from this out enemy, we're going to see if it is valid. If it is not valid, that's kind of a problem. You might want to print a string, because again, like I was saying earlier, this is kind of game breaking. This is going to really mess up your game if it fails. Which is why we don't support failing. We support succeeding at pretty much any cost, right? So this should always succeed, and then when it does, I want to activate an enemy. And activate an enemy is going to be a custom event that we call just activate enemy. And activate enemy is going to take in the enemy, so it's going to take in an actor. Hard object reference, not class reference. This is enemy, and it's going to take in a location of spawn location, and that is just going to call the I return to play message with that spawn location. I could just call the I return to play message, but I call this in a few different places, and I wanted to just call it like that. I know it's a little weird, but I figure there may be circumstances where I need to activate an enemy anyway, so I might as well just make an activate enemy function and use that everywhere else, or everywhere that an enemy needs to be activated anyway. So now we need to run a little bit more logic, right? Because we have spawned our enemy. Our enemy should no longer exist inside of this enemies for wave pool, because if it does, then we're going to duplicate spawn it on accident at some point. So we need to take our enemies for wave before we end out this function, and we need to find this local rolled enemy in there. Okay, we got to find that local rolled enemy. We're going to -1 from that amount of that local rolled enemy if we found it. So if we found it, we're going to -1, and we're going to say if that equals, so less than or equal to 0. And if that is less than or equal to 0, then we need to remove this entry from the map. So we're going to take both of these again up here. We're just going to say remove this entry because there are no longer enemies of this type that exist. And even if it is in there at 0, then random is still going to pull it. So we want to make sure that when it's 0, it gets removed. When it's not 0, we are going to add, again, this local rolled enemy back in at -1. Okay, so hopefully that makes sense. Add does not add. I've said this a few times. I don't I guess it can be a little confusing. If you already have this rolled enemy in here, what this add is going to do is replace the entry completely. It's not going to add onto it. So if you have this local rolled enemy mapped to 5, right? We just spawned the enemy. Now we want to find it. It's at 5. 5 minus 1 is 4. 4 is not less than or equal to 0. So we're going to be running this false, and we're going to be adding it in at 4. That's not going to say 4 plus 5 and make it 9. That's going to just replace the entry entirely that was 5 with the new entry of 4. Okay, hopefully that makes sense. We're going to move on from that. And that is our handle enemy spawn. So I know we did a lot of stuff there. Hopefully you're keeping up with us. We're getting pretty deep in the paint with this wave manager component. I'd say we're getting pretty close to done. Unfortunately, it's getting really hot in my house because we've been doing this for 2 hours and I can't run the AC while I'm recording. Otherwise, you guys won't be able to hear me. But yeah, I think we're pretty much well on our way. I can go ahead and close 90% of this stuff as well. Okay, so now we're going to work on the enemy events. So basically activating and deactivating the enemies and all that good stuff. We'll work on the setup and wave management in a little bit. One thing I want to say on this activate enemy is we do want to make sure it is valid first. Otherwise, we're going to have errors because if for whatever reason this enemy is not valid, we want to just remove them from the pool. So we're going to, we're not even going to remove them from the pool because they're not valid. So yeah, we just want to make sure that this enemy is valid before we return to play. Otherwise, we're going to have probably a bad time. And then we want to make another custom event here called Deactivate. So Deactivate enemy. And this is going to be slightly different from the version that I did with the shorter tutorial series. We're going to make this actor because it's just named a little bit differently. That's all. And this is going to be enemy. Deactivate enemy is just going to see if the enemy is valid. If it is valid, we're going to call I remove from play. Just like we added return to play up there, we're going to add remove from play down here. And we're going to use the pool location this time instead of the spawn location where we had to do all that logic to figure it out. Okay? So to go along with despawn enemy, we need another custom event here called kill enemy, or I guess kill enemy is fine. I probably shouldn't say kill on YouTube, but kill enemy is fine, and that's going to take in an actor reference of the enemy ref that we're going to be essentially killing. So this is going to run first a custom event called handle enemy death, and that custom event is going to be over here for now, and we're going to run that. So handle enemy death. And handle enemy death doesn't do much. We'll get into that in just a second. And then we're going to route this down and say deactivate enemy. Because now we want the enemy to be deactivated. We're not calling deactivate enemy when we kill an enemy. We're calling kill enemy. That way we have this function here as an intermediate function to basically handle all of the scoring logic and everything. We could handle all of the scoring logic here because handle enemy death it doesn't do much, but it does enough that I don't want to have to handle it inside of this function. I want to handle it wherever I decide to handle it. So handle enemy death is going to take active enemies. That integer we made a little while ago. We're not going to subtract. We're going to decrement. So we're going to take active enemies. We're going to decrement from active enemies because there's one fewer enemy active in the field. We need another one here called enemies killed. So enemies, we'll take active enemies and say enemies killed. And we're going to increment enemies killed. That way we can check and see if we've killed enough enemies to end the wave. We're going to get game state here again to update the UI with the enemy killed. Because we want every player in the game to know that an enemy has been killed. It's not a boss. And then we're going to run a branch because we need to see if our enemies killed, so that value we just incremented, is greater than or equal to our, I'll just pull it out again, spawner details, total enemies. So if we've killed more enemies than the total enemies for the wave, then we're good. We end the wave, right? We have completed the objective, and we're going to call end wave as a custom event. And that's just going to go up here with start wave for now. And we're going to build that out later when we build those out. For now, we just need to know that, yeah, if we killed all the enemies, then the wave is over. We can end it. Now, if we did not kill all the enemies and the wave is not over, we need to check our spawn timer handle is valid. Because if it is still valid and paused, we need to make sure that we are restarting it. So we're going to say is valid timer handle and is timer pause. So if it is a valid timer handle and it is paused, then we are just going to take it and unpause it. Because this is, again, if we spawned up to the max alive, but we still have more enemies to spawn, well, now that we've killed an enemy, we need to check and see if this is a valid timer handle, so we haven't invalidated it by spawning max enemy or total enemies, or not using overspawn, right? It's still valid. If it's paused, then we need to unpause it. But we do need to make sure it's valid, because if it's not valid and we try to start it, we're going to have a bad time. We're going to start spawning enemies that we don't need to be spawning in here. And end wave is going to handle spawn timer itself as well. But that's all that needs to happen inside of handle enemy death. So that one's pretty simple as well. I'm going to move these up over here a little bit. We're going to be collapsing this in just a minute. We need another one here called spawn boss. Because I'm not pooling bosses. If you want to pool bosses, you can. Again, it's kind of questionable whether or not we even should have supported bosses. But we're going to need the actor soft class reference and a vector for location. So spawn location and boss ref. And we're going to take this soft boss class reference. We're going to load asset blocking. Because when we load the boss, it needs to be loaded immediately. We're going to cast to actor, which I spelled it tactor. We're going to cast to the actor class. From the actor class, we're going to spawn actor from class. And we're going to make sure, again, we split this location, set it to the pool location. So it might be worth making a custom function or event that just kind of does this for us. But then we're going to return to play from the boss with the spawn location as its location. Because, again, we want to make sure that the boss is visible, right? Its collisions are properly enabled. It has whatever its health is. It's set to being active, so it's not going to try to get respawned if we ever do multi-bossing or anything like that. So, yeah, we're just going to make sure we put it at the pool location and return it to play. We put it at the pool location so it doesn't fall through the map. I had that happen with the... if you watch it, the shorter series, we actually didn't put a location in here, and it ended up spawning in the middle of nowhere, and the boss would die, and we had a bad time. So yeah, something to keep in mind there. If you spawn at 0, and 0 is under your world, then the boss will just fall through the floor, and you'll have a very bad time. So that is spawn the boss. We have 2 more things that happen in here. So we have one thing that is pretty simple, and this gets called by end wave, and this is going to be cleanup. Technically, this could get called before end wave if we really wanted to. We could call it right here, but I call it in end wave. We take our spawn timer handle, we clear and invalidate it because we are no longer in the wave. And then we take our active enemies or enemy pool, and we run a for each loop through that just to make sure that despawn enemy, deactivate enemy. Then we're going to call deactivate enemy from that to basically make sure that the enemy is getting properly, all of the enemies are getting properly deactivated, which is just making sure they're valid and removing them from play and putting them in the pool. And that's all cleanup enemies is going to do. And then we need one more function in here, which is going to be to handle the boss death. And I want to put that like right here. So last event, handle boss death. Handle boss death is going to, once again, get to game mode and call the enemy killed message. But this time it is going to be boss because we just killed the boss. We're going to take and see if our spawn timer handle is valid. If it is valid for whatever reason, we're going to clear and invalidate it. which I don't actually think I need this check. I'm going to go without this check because it's never been a problem to me before to try to clear and invalidate a spawn timer handle that doesn't exist. It's never given me an error, so I don't think I need that check there. But if you've experienced errors with spawn timer handles in the past, you might want that check. And then we're just going to call end wave. This one, again, I don't think we need to actually clear and invalidate the timer handle here, since we're going to be doing that on end wave anyway. Yeah, so we'll just call end wave. So basically, we just want to know that the boss has been killed and the wave is over. And then on end wave, we'll just do this real quick. We're not going to build it out. We're just going to say cleanup. Clean up enemies on end wave. That way we know that we are always running cleanup enemies, which is going to clear and invalidate the spawn timer handle and handle all that for us. So yeah, I'm going to comment all of this. I'm not going to comment it. I'm going to collapse this, and this is going to be my enemy events. I'll actually just call, yeah. And this is going to be my enemy events node. So all of those functions are going to get collapsed into here. Now we have them in a dropdown, and we can handle them all. So now we really want to determine how our pool is going to be set up. Okay, how our pool is going to be set up. And these are pretty complex functions that we're going to build here, but they're very important for making sure that everything works the way it's supposed to. So we have one custom event here, which is going to be called calculate needs. And we have another one that is going to be called prepare enemies. And these are both going to rely on a lot of internal functions to work. So we're going to go ahead and just start building them out from the top down. So the first thing we're going to do on calculate needs is take both these enemy maps and clear them. Because this is where we're going to be making those enemy maps. So we're going to clear enemies 4 wave and we're going to clear enemies 2 spawn. Because we want to make sure that nothing is lingering in there to mess up the system. Okay? Now we're going to run a for loop. And this for loop is going to be coming out of our spawner details. We're going to break that open. And we're going to get the total enemies as the last index. And the first index is going to be 1. So basically we are spawning all of the enemies, or determining, I should say, all of the enemies that we are going to need in this wave. So we're going to be running the RNG on all of the enemies here to figure out what we need in this wave. So I'm going to take my enemy classes, I'm going to get a random array item, and I'm going to take my use weights into a select. I'm just going to say select and make a selector class. And we're going to use random for the false. So if use weights is false, then we are just going to take a random out of here. If you're not using use weights, you could say is empty on this array. And that would work perfectly fine. I just think the Boolean's a little bit easier to see here. And if that is true, we need to build a function in order to basically get the Wade spawn. And we're going to do that right now. We're going to make a function called the get Wade spawn. This is going to be a pure function. And this is going to output an actor soft class reference. And this is going to be rolled enemy. And it's going to take in an array of soft class actors called in enemies. And it's going to take in an array of floats called in weights. Okay? You may be wondering why I don't just grab the spawner details and break it, and that's just because I don't feel like doing it every single time in here. What we're going to do is, in our event graph, when we call this get Wade spawn, we're just going to pass those in. That way I don't have to break this open and get it every single time. I need them inside this function. It's just a nice pure function. Takes inputs, gives outputs. This could even be put on a BPFL if you wanted. So we're going to take this, basically both of these arrays and see if they're not empty. So is not empty and is not empty for both of these. So and, because if either of these is empty, we kind of have our first problem and we need to handle that. Otherwise, we're not going to be able to roll the system, right? And odds are, if one of these is empty, it's probably going to be weights. Weights shouldn't be empty, but it probably, if we're doing this, it's probably weights. So we need to get the in enemy classes. So get in enemy classes or in enemies, and say is empty. And again, this is just the input variable of this function, so in enemies, whatever you called it. And if this is empty, that's kind of a problem. We need to print a string that says we have failed at life or something like that, and return empty. Okay? Because there's a problem. If it is not empty, then we are just going to return a random item like we did before. This should not be happening. A way to make sure this doesn't happen would be to not use a boolean for use waits. It would be to see if waits is empty, and then this would literally never happen. But if for some reason you wanted to use waits and you thought you put something in there and you didn't, this will trigger. So you may also want a print string here as well. This should not trigger. And we want to know if it does trigger, but we don't want to stop gameplay if it does trigger. So now we're also going to take our in waits and we're going to run some math on this in waits. Now I'm not a mathematician, but I wanted to make something that was a little bit neater and cooler than random. That way we could have some semblance of waits in our system. So we're going to run in waits through a for each loop. And I'm going to promote this array element to a local variable, and we're going to call this L total. And I'm going to duplicate L total for L cumulative. And I'm going to duplicate that again for L rand. And we'll get to anything else that we need later on. Basically, this is going to set L total to whatever the total currently is. So the total is going to start at 0. And we're going to add all of the array elements inside of this waits array up to get a total. Once we have a total, we can check and see if that total is equal to 0. If that total is equal to 0, that's kind of a problem. And we need to handle that, right? Because then something has happened inside of our waits. Our waits have run, and I guess maybe we had 0 in all of them or something like that. I don't see why this would happen, but I'm going to route this down here anyway for our fallback, since we have 2 fallbacks. I don't see why it would happen, but I'm not going to put it past me to somehow make this happen. So this L rand needs to get set now, and we're going to say random float in range. If you want to use a stream or seed stream, that's totally something that's up to you. I don't think I need it here. Or I really don't feel like I need it here, so I'm not going to use it here. I'm just going to use our total to get a local rand. And that's worked for me fine. It's replicated fine. If you have this, for whatever reason, this component on like an actor in the game, you'll probably want to get a seed from the game mode. That way you're replicating the seed. Otherwise, you're going to have probably a bad time. Because this won't be on the... You're going to have a bad time anyway, because this won't be on the game mode. That's why we put this on the game mode, so we don't really have to worry about this running 3 different times and trying to give different values. It's only going to run once, it's going to give the same value, and that value is then going to get pushed down to all of the clients and the server player, which is why we do it this way. So we need to take our in waits again, and this time we're going to run a for each with break. Excuse me. A for each with break. Because now we have kind of run through, we've got our random, we've got our total, we need to figure out what index in this waits we're going to be pulling from, and we're going to use that index to get a copy of it at this enemies to basically say, okay, this is the enemy we have spawned, or we want to spawn. And this is where cumulative is going to come in, and cumulative is going to do the same thing total did earlier. We're going to add the array element and set cumulative to that. And once we have set cumulative, we're going to move this down a little bit more so it's out of the way. Once we have set cumulative, we're going to see if rand is less than or equal to our cumulative value. I believe it's less than or equal to. Again, I'm not a mathematician, so if you notice anything not working properly in your game, you could probably blame me. It's probably my math. And if that is true, if the cumulative is less than the random, then I want to return the array index. You could do greater than as well, but I think I just did mine when I set it up as a less than system. I actually did some testing and it didn't matter at all, so whatever. We're going to make this L index local variable and set that on true. And then break. But we need some way to check this L index to make sure that it doesn't fail. It doesn't come up -1. So for the default value, we're just going to make that -1. And the first thing we're going to do down here when we're done is actually check and see if that is less than or equal to, it should just be equal to, -1. I don't know why I put a less than in my example project, but I guess I'm just going to keep doing it. Bad habits die hard. We're going to run a branch on that less than or equal to 1. And if that is true, we're going to route that down here to this fallback. And this fallback is just going to take the get in enemies and get a random array item out of that and return it. Because again, we don't want to fail the gameplay loop if we mess something up along the way, just because of this. We just kind of want to handle it gracefully, and some people might not set everything up properly and be doing this. So I'm also going to print a string that says wait spawn failed. That way we know what's going on with our game, right? Because if this stuff fails, we want these fallbacks to have some kind of string in them. I didn't do this in the shorter tutorial series, but since we're kind of all here together and I don't have to worry about time limits, it's a little bit nice to be able to just print strings as we're going along. Especially since we're building all this at once without testing it, too. We want to make sure that we're printing strings. Otherwise, we could have a pretty bad time. So we want to make sure that this index, which is never going to be... I don't know why I ran this check either. This index is going to be greater than or equal to the length of the last enemy. So if this is greater than the index of the last enemies, that's kind of a problem as well, and we need to handle that. Because something has gone wrong with our weights. Maybe we have more weights than enemies. In the other tutorial series, I used weights here for the length. I definitely need to make a video where I correct that now. But off of our false here, we're going to return a copy of the index that we rolled. Because this is valid, right? This is a valid index. So you could also say valid index. I guess valid index probably works a little bit better here for what we want to accomplish, which is making sure that we're returning a valid enemy. And if it is a valid index, then we would do this. If it is not a valid index, then we would grab the last index and get a copy of the last index and return. I didn't want enemies. And return that. So I know that's a little sloppy. Basically, we're just getting the index of the enemies if it succeeds, if this is a valid index. And if it's not a valid index, we're just getting a copy of the last index. Or you could route this up to this fallback as well. It doesn't matter too much. But basically, this just says that there were more weights than enemies, or more enemies. We didn't get a valid pull, so we need to do something else. So I guess maybe a better way to do this might be to just say is valid index here off of this, and if that returns true, we do this. If that returns false, we do this, and we don't need this second branch at all. So we don't need this, and we don't need that. If that is true, we'll just add the enemy. If it is false, then we'll just carry on with our fallback over here, right, and get the random. So yeah, I think that's fine. I think doing it that way is honestly a little bit easier to read in the future anyway. I wanted to like pull the last index to be able to get the lowest chance enemy, but this is fine. Just pulling a random here is totally fine. Arguably easier. Yeah, that is our get weight spawn. So that is basically always returning something for the enemy class, no matter what we do. And we're going to go ahead and implement that in our event graph. So we already have implemented that in the event graph here. And this is running the for loop again while we're setting up our enemy's for wave. So we're going to promote this to a variable, and I needed this to be a variable because we didn't want to run this weighted spawn in random after checking to see if it's valid. Okay, and I was a little worried about whether or not it was going to run that check. So we're going to promote this to a variable. And we're just going to set this to selected actor, and we're just going to put it in management, I guess. Because again, we want to make sure that we're not, like, when we run this is valid actor, and we branch, we want to make sure that we're getting the same pull when we do all this logic, whereas if we pull off of these multiple times, it's probably going to get a different pull every single execution, every single wire, and we don't want that. Because these are randoms. We want to go ahead and just cache a reference to our actor. That way we know for sure that we are doing what we need to do False needs to print a string because this is a bad time. We failed at life again. So we're going to say we failed the random enemy. And then if this is true, we're going to add to this enemy's for wave, because that's what we're determining right now, the selected actor. And we need to decide whether or not we are putting 1 or +1 here. Now, I'm not sure entirely because I've always kind of done it this way, but if I take selected actor and I take the enemies for wave and we find the actor in here, I'm not sure if when it doesn't find the enemy, if that returns 0, or if it returns something else. I should probably figure out at some point, because that would make my life easier. But what I'm going to do is I'm just going to select an int with this boolean on the find, because this is how I've kind of always done it. If we found it, then we pick A. If we did not find it, then we pick B. And on A, we want to add 1. I don't know why I plugged that into B. And on B, we need to just say it is 1. So add 1 on A, and just 1 on B. Because we didn't find it, then it doesn't exist, so we just need to add it with an amount of 1. If it already does exist, then we need to replace it with whatever value we had, plus 1. Again, I don't know if we need this selector here. I think that would return 0, so you should just be able to say +1. But I want it to be sure. And then when this is all said and done, we need to prepare the enemies, because that's all this is doing is just, again, looping through all of the enemy classes and weights we have set up for the wave, getting a random enemy every single time. It's going to get a different weight spawn or a different random, and we're going to just add that in. Okay? And this might be something later on that I actually collapse to a function. That way we can just return probably a map and set it. We could even have this as a pure function, honestly. But for now, I think it's fine. Now, prepare enemies is more or less going to do something similar, except with the enemies to spawn. Okay? And with the enemies to spawn, we are going to be setting that. But we need to first run a branch, because we need to check something first. And if that something is false, then we are going to set this. And we're not going to do anything off of true. Because we might already have all of the enemies that we need in the pool. This isn't always going to prepare enemies. If we already have 10 goblins and we roll 10 goblins, and then this formula we're about to make is going to come up empty. And if it's empty, that's fine. We just don't need to do anything because we've already spawned all the enemies that we need. They're already in the pool. We don't need to add any more enemies to the pool. So yeah, yeah. So what we're going to do after that is we're going to say keys, because that is a pretty complex function. So basically we just know that if this function fails, we need to spawn enemies. And if we start spawning enemies, this is how we're going to do it. So we're going to do keys, and then we're going to do a for each loop, and this is the enemies to spawn. Yeah. For each loop on the enemies to spawn, which is going to get the enemies to spawn again. It's going to find the array elements in there, unless you have the plugin for advanced maps, which is a neato plugin. I don't have it. We're going to run a for loop on that loop body. So for every enemy in this, so we're going to start at 1. For every enemy in this name, so every enemy of this actor type, so we have actor goblin, and then we have amount of 5. So we're going to find the amount for goblin, which is going to be 5, and we're going to do this 1, 2, 3, 4, 5 times, or you could subtract 1 at the end and start from the first index of 0. I just start from 1. Personal thing for me. Bothers me starting at doing the -1, honestly. So yeah, when this happens, we're going to load the class asset blocking, because this is where we are loading the enemies in. Now, we don't necessarily need to do this blocking. If your assets are huge, we could probably get away with async. But I didn't notice any kind of difference between doing this async and doing this non-async. So actually, we'll just, I guess, do it async in this example. Since we did it non-async in the other example, we'll do it async in this example. And we're going to async load asset blocking, and then when that is done, we are going to cast to actor class on the completed. We want to cast to the actor class. We're not doing anything while this is asyncing. And then we are going to spawn actor from class, just like we did earlier. We're going to split the transform. We're going to put the pool location in there. This is when we're actually spawning all of the enemies, right, for the wave we're about to encounter. During the pre-wave, to make sure that they're all loaded into the game before we actually start the wave, and then we get a bunch of lag because 50 enemies just tried to load themselves into the game. We're going to take the enemy pool. We're going to add that to the enemy pool. And then we are going to despawn that enemy. So deactivate that enemy. Remember, deactivate enemy doesn't do anything with the score. We're basically just making sure that the enemy itself is properly sitting in its pin with no HP, because if it has HP, then something might damage it. If it has the active tag, then we're going to have a bad time, right? We want to make sure we're setting all those values back to whatever they are supposed to be when the enemy is deactivated. And that's actually all that's going to happen here. I know this is pretty simple, but this part here is not. So we need a new function, and this function is going to be pure, and it is just going to return a map. And it's going to be calculate new spawns required. I'm going to make my life easy here. I'm going to add the return node. I'm just going to drag this in because it's the same map type I want, and then I'm going to delete it. This is going to be pure, and we need multiple different routes to come out of here. So we're going to need this a couple of times. And we're also going to need a local version of this map, so we're going to promote this to a local variable as well called lmap. One more thing we're going to need is our enemy pool, and we're going to need a local version of that as well. Because what we're going to do is we're going to take our enemies for the wave. We're going to loop through our enemy pool to find those enemies. We're going to make a local version of it. Remove enemies from that local pool as they are in this map. And then we are going to add any remainder to the local map, which we're going to return, which is going to be the enemies for wave, which is what is going to get set when we call this. So we'll finish this up here. When we call this, so we're going to say is empty. And if it is not empty, we are going to set it. But I'm actually going to just set it first, because I think I'm pretty sure we have to calculate this twice. If I drag off of it twice, and I don't want to do that. So we're going to set enemies to spawn. So I guess there's really not much point in this being impure. Then we're going to see if that is empty. If that is empty, then we're not going to do anything. If it's not empty, then we are going to take our enemies to spawn, get the keys, and do whatever it is that we're doing. Yeah, that looks a little bit cleaner to me. I like that a little bit better. Yeah, because now we're just setting it once. Now we know we're only using this pure function once. If you want to not deal with that, just don't make it pure and make it set the enemies for wave inside of itself. But this is the way I decided to do it, so this is how it's going to go. We need to take our enemy pool first. We need to see if our enemy pool is empty. Because this is pretty important. This might be the first wave, or you might have just done a periodic cleanup, which we'll get to later. And if this enemy pool is empty, then essentially we need to spawn all of the enemies for the wave, right? Or this should be enemies to spawn, by the way. We need to take all of the enemies for the wave and make that the enemies to spawn, because we don't have any enemies. Now, you might want to clamp this off. Again, like we were talking about earlier, if you are being very restrictive, maybe you have very high poly assets, maybe they have very complex logic, and you're being very restrictive with the amount that you can have alive at once, but not necessarily the amount that's in a wave. You might want to clamp this off to make sure that this is not doing what it's supposed to be doing. So you would say, we need to do keys, because keys works a little bit better for what we need to do. We're going to say keys, run that through the keys, and then, yeah, find the array element. If the array element is greater than 25, then we need to add it back in at a clamped value, right? Or some kind of logic there to clamp this in. I'm not too worried about it because I'm not running anything that complicated in my game. But you might want to consider that if you are running very complicated enemies or having issues otherwise with the spawner system, not spawning in too many enemies or something like that. But I handle things weird, so I don't need it. I'll be honest with you, I handle things weird. Anyway, our enemy pool needs to get promoted to a local variable, like I mentioned earlier, called lpool. Because we're going to be manipulating this pool. So we don't want to use the actual enemy pool. Otherwise, we're going to have a bad time. We want to manipulate a local version of that pool. Now we're going to take enemies for wave. We're going to do keys. We're going to run a for each through keys. We're going to promote this to a local variable called LDesired. This is the desired enemy. We are going to find that in the map. And off of this found, we are going to promote this to a local variable and say L amount. And this is just for convenience, honestly. Just for convenience, because I don't feel like dealing with it. And then we're going to add a return node here. At the end of this for each loop, which is keying through all of the enemies for the wave, we're going to return the map, because we'll be done when this is over. We're going to be running a couple of other things in here, which is why we set these to local variables. Okay, so now we're going to run a for loop again. And this one is going to start at 1 as well, because I like starting them at 1 with maps. You could subtract 1 off of this value. And we're going to clamp that local amount, and this is kind of my safety, to the spawner details, break, max alive, just to make sure that we are never, and it should never happen, but just to make sure that we're never spawning more than the max alive of any given enemy type. You could probably even divide this by the amount and do some complex calculations by your weights to determine how many of each you're going to have, or yeah, do it by this amount divided by max alive or some other math. But again, I'm not a mathematician, so we don't want to be here for 5 hours talking about it. So we're just going to clamp to the max alive. That way we might need 500,000 goblins for a wave for some reason. But we can only ever have 100 goblins alive at a time. We don't need to pool 5,000 goblins. We just need to pool 100 goblins, because that's the absolute max that can ever be alive at a time. So hopefully that makes sense. We need one more local variable here, and that is going to be L found, and this is going to be a Boolean, just a normal single Boolean. And L found is just going to get reset every time we run this loop to make sure it is false before we run it. This loop is going to be a for each with break on the local pool. So we're going to say for each with break on the local pool, because this break is going to be basically meaning we found an enemy. So we're going to get our L desired. We're going to say is valid. Again, we always check valid on these soft class references, because if they're not valid for some reason, we have a problem. And if that is valid, then I should say if that's not valid, we need to print a string. You should be more descriptive than soft failed, but I'm getting tired of talking, so I want to finish this video. We're going to run a branch, and we're going to make sure that local desired is equal to, again, the get class of the actor. So this is a hard actor. We're getting its class reference, and then we're seeing if that class reference is equal to the soft class reference. And if that is true, we're going to set L found to true, and we're just going to go ahead and break. But first we need the index of the where this was found. So we're going to take index, and we're going to promote that to a local variable called L index. Because we need to cache this index. That way we can remove the index in just a moment. So when that's broken, I guess you could say index -1 for that, but I like the Boolean here. We're going to say if L found is true, then we need to do something, and if L found is not true, then we need to do something. If L found is true, then we're going to take the local index, we're going to take the local pool, and we're going to remove the index from the pool, because we no longer want to do it. We no longer want this index. Next time we loop through this, we're going to loop through this, 50 times? Next time we loop through this local pool will not have this index, and now if we go through it and none of the classes match, then we will go ahead and fail this found. And when we fail this found, we're going to take the local map and do like we did earlier. We're going to find the local desired, and then add 1 if it's valid, through a selection to add an entry into this map of the local desired, and the amount is going to be select int. If it is, if it is found, then we say +1. If it is not found, then we say 1. That way we add 1. Again, you should not have to use the selector. You can probably just say plus on the find, and you'll probably get 1 if nothing is found. I'm like almost positive, but almost positive doesn't pay the bills. So yeah, that's what we're gonna do. I know I went through that pretty fast. Basically, when an entry is not found in the pool, we're just gonna add that to the map and do it again. So if we were rolling through 15 goblins and we didn't find a goblin on the first one, yes, we are going to roll this 15 times to basically add all of the goblins in. Another way to do this, you could improve this a little bit. So we could take amount and we could decrement amount every time we do this, and basically say for loop with break, and when we hit false, we add the remaining amount as an entry, and then break the for loop, and then it'll come back here and do the next entry. But I really didn't want to complicate this because it's already, I think, complicated enough for most of us. And we're pretty good, I think, where we are. It might just have to loop through things a little bit more. And I'm not adding 5,000 enemies. If you're adding 5,000 enemies and you have some massive horde game, then yeah, for sure you're gonna wanna make sure that you set like number values to not have to do this 5,000 times. If you have to do this 5,000 times, you're probably gonna have a very bad time, right? This is not gonna hold up well to 5,000 times needing to be run. It might hold up, but probably not well. Let's be honest. So yeah, that is the calculate new spawns required, and that's going to set the enemies to spawn, check and see if it's empty. If it's not empty, then we're going to go ahead and spawn all of those enemies, and make sure that they are deactive and waiting for the pool, so when the wave starts, we pull them from the pool. You don't necessarily need to do this either, because the way we have everything set up, we've decided that when we need an enemy, if we don't already have them, for any reason, we are spawning them on the spot. So you don't necessarily need to pre-spawn these pools. I think it's useful because we're spawning like 20 or 30 goblins in here, right? I don't want to have to spawn those every single time they need to get spawned. But I also don't think this is actually making much of an impact performance-wise. Again, the largest performance factor by far is the character movement component, which there's not a whole heck of a lot we can really do about. This spawner system didn't even register. The one time it registered in prepare enemies because we were spawning 55 enemies at once. And that was the only time it registered. It registered for a single frame between waves, which was ideal. But so something to keep in mind there. I guess you don't necessarily need these functions, but they are very useful. So let's go ahead and get started on the wave management graph. Now this is where we're probably going to have to make a data table and do a bunch of other stuff before we wrap up with the spawner system and finally get to test it. But yeah, what we're going to do here is we are going to start next wave first because we already have it. That's going to take the spawner details and break it because we need to know if this is a boss wave. So we're going to take boss wave, boss wave, and branch. We're also going to need to know if it's only boss, so we'll take that out now as well. And we're probably going to need the boss class. I'm just going to route that over here so I have access to it and I can condense this break. So if it is not a boss, then we can just go ahead and start spawner. Start the spawner timer because it's time to start the next wave. It's not a boss. All right, go ahead, start the spawn timer. If it is a boss, we need to see if it's only boss. If it's only boss, we don't start the spawn timer. If it's not only boss, then we also start the spawn timer because we're going to be spawning minions along with the boss. Now, whether that is true or false, we need to spawn the boss. Like we said earlier, when we made that function, we needed to go ahead and spawn the boss because this is a boss wave. And in order to spawn the boss, we need the boss ref, and I'm just going to actually route that over here because it looks a little bit cleaner. And as for the location, we should always have a valid location in this boss spawn pads. But we might not, so we're going to say is empty. Oh, that reminds me. But first we actually need to set up those spawn pads, otherwise we're not going to have a valid location in there. So set up the boss pad here. Remember, this is happening after we have already set up all of the pads for wave through the normal pad setup, which is why we can just start spawning the enemies without setting up the pads because we've already set up the enemy pads. We just haven't set up the boss pad because we didn't know if it was a boss wave or not. And we only want to check that in one place, and that place is right here. The only place that really matters. So yeah, now we should have a valid boss location. If we don't have a valid boss location, I want to handle that gracefully because I like handling things gracefully. And we're going to say random is B if this is empty. Pick A, and A is going to be spawn pads. We're just going to pluck a random spawn pad location in there. Again, you might not want to do this. This is just gonna be like if you forgot to put the boss pad out in the world for some reason, or it didn't get activated, or you used some weird location. We're just gonna try to get a valid pad to basically spawn the boss somewhere. That way we don't fail out of this game. You might want to fail out of this game right now if your boss pads aren't set up, because you need the boss to spawn in a very specific location. I don't actually need the boss to spawn in a very specific location. I just like having the boss pads. So if I accidentally forget in a map, it won't be the end of the world. I'll be prototyping. I'll be like, where the heck is the boss in the middle of the floor? And it'll be because this is empty. So yeah, maybe you want to add a branch in here too to have branching logic to make sure that it's not empty before you do this, to add a print string. And I'm not worried about it. I don't think it matters that much. Again, we're lucky we even supported bossing here at all. So whatever happens with the boss is something we can expand on in the future. And then obviously after we spawn the boss, we need to increment our enemies alive and our spawned enemies, right? So we need to take our enemies spawned and our active enemies. Find them in here. Active enemies. And increment both of those because we have spawned an enemy. Just because it's a boss doesn't mean it's not an enemy. Unless you don't want your boss to be an enemy for some unknown reason. Anyway, yeah, we're just going to say that. And now our boss has spawned in, our active enemies has increased. That's all spawning the boss is going to do, really. Since we have end wave as well, we'll go ahead and end wave. So we'll start the wave, we'll end the wave, and then we'll do the pre-wave function. There's only 3 main events. There's technically 4 events, but... so this is pretty simple. We're going to take active enemies, we're going to take enemies spawned, we're going to take enemies killed, 0 all of these things out because we need them to be 0 for the next wave, otherwise we're going to have a bad time before we even start calculating our stuff. We need to see if the wave, because we're going to use a periodic cleanup system, if the wave to float, and we're going to do this twice, so make sure you pay attention. Division, whole, and remainder. So we're going to run division, whole, and remainder on the wave as a float. And see if the divisor of 10 is equal to a remainder of 0. And we have a setup variable called use periodic cleanup to basically see if we are using periodic cleanup. And we're going to run that into a branch, not a do once, a branch. Which is going to do a custom event called periodic cleanup. So I guess I explained that kind of fast. Hopefully you understood. But basically what happens here is we're just dividing the current wave by whether or not this was the 10th wave. So if this is the wave 10, if this is wave 20, 30, 40, 50... the remainder is always going to be 0. It's going to be a whole number that we get out of dividing this number. And that is going to basically be determining whether or not we are going to use periodic cleanup. That and the setup variable of use periodic cleanup, which I will make true, because I do want to use periodic cleanup. And if both of those are true, then we're going to use periodic cleanup to do some stuff. And if neither of those are true, now we're going to take our wave. So this happens after wave 10, before wave 11. And increment it. We could make this happen before wave 10, so after wave 9, but I decided to make it happen after wave 10 because we might have enemies in with the boss that like symbolize the wave grouping of 10, or you could even change this and make it 5 or any other number, as long as you can get a remainder that is going to be consistent and scalable. 10 is just the easiest thing to be consistently scalable. And then we're going to start countdown timer. And we're going to run another custom event, which is going to be the last one we're going to make here, called setup next wave. Okay, so hopefully all that makes sense. And if you don't want to use periodic cleanup, you don't have to. We're going to build that next. But it's just kind of a handy little feature that I thought would be useful, because let's say we are spawning waves 0 through 10 in this mode are just goblin waves, and waves 20 through 30 are the robot waves, and we don't want to keep a bunch of goblins around if we're not going to need goblins again in the near future. So we're just going to destroy all those goblins and basically clear the enemy pool container, not spawn pads. clear the enemy pool container to say that we no longer have any pooled enemies. And again, this is kind of if your enemies are like really escalating in difficulty, or maybe you needed a lot of enemies and then you won't need those enemies again. You know you won't need them again because the game type's changed or something has changed. You could use periodic cleanup here to basically just clean up all the enemies, destroy them all, and clear out that pool so you can start with a fresh pool on the next wave. I like to do that every 10 waves because I think my system is probably going to increase the enemy classes and have the enemy classes use advanced AI, right? Slightly advanced AI when this happens. When we go over a 10th wave threshold, right? Up to a certain degree anyway. So I do want to use this periodic cleanup. And if you reach like wave 50 and you divide by 50 and the divisor and return value equals 0 or 1, or the return value would equal 1 if it's 50 divided by 50, then you would say set use periodic cleanup to false. Like if you have forever game and you're going to keep spawning the same enemy forever and ever and ever, after a certain point, you would determine that point, run division whole and remainder. If you're equal to that point, you would set use periodic cleanup to false inside of the graph. I'm not worried about it right now. That's a little more complicated than I want to get into, and it's very specific to a use case that would need it. I guess use periodic cleanup is pretty specific to a use case as well, but I think it's at least more useful than the other thing. So, set up next wave. In my example, I ran a switch on authority. You don't need to run a switch as authority because it's going to have the authority. I just ran one because I get in the habit of running things. I put switches everywhere pretty much when I'm prototyping. But yeah, you don't need that switch. Basically, what's going to happen here is we're going to see if the wave, and we're going to need some more setup values. Setup is going to be very important here. We're going to see if the wave is less than or equal to the max data table wave. So we're going to promote this to a variable and call it max data table wave. Because we're going to need this max data table wave in the setup to be set up when we make our data table. For me, that's going to be 13, but for you, that's going to be whatever the last wave of your curated data table is. Now, if you want to use multiple data tables as well here, that's totally a thing you can do. We're just going to use one and keep it pretty simple so that we don't have to deal with that too much. We need another setup variable of the type Boolean, which is use data table. Because we need to make sure that use data table is also true. If you don't want to be using data tables, then it's easy enough to come in here and set this to false in the setup and then not use data tables at all. Totally up to you and your situation. I figure I might have situations where I do both, right? Where I do both. So to do the data table, we need the data table. So we're going to come into our data folder where we made our structure for our spawner details. We're going to go into blueprint. Not blueprint. We're going to go into miscellaneous and we're going to make a data table. And that data table is going to be based on the spawner detail structure. And I'm going to call this DT spawner details. You could use a data asset or something else if you want. I like data tables. I think they're really fast to set up. And basically, we're just going to set this up with a bunch of values. What I'm going to do for you, we did it the hard way in the demo, the broken up tutorial series. But since we're 3 hours in here, what I'm actually going to do is I'm just going to export the data table that I had in my example project. So I'm going to export that as a CSV. I will, I guess, save it somewhere on my desktop. That way I can upload it back to you guys later. And we'll upload that to the cloud. So we'll call this something like spawn details data. And I will re-import my spawn details data. Why did that go in there? Excuse me. Anyway, I'll import that spawn details data. And that's going to have all of the, basically just set up the same way that we were talking about. So, you know, is it a boss class? What is the spawn interval? Are we using weights? What are the weights? What enemy are we spawning? And the enemy classes here are all going to be wrong because they don't exist. So if I try to save this, it might give me grief. It didn't give me grief. Okay. It should have given me grief, but we're going to make these enemy classes in just a second as well. That way we're getting like different enemies spawning in here. And the boss class is boss wave and only boss. We'll click only boss with one enemy. And the active pad here, we actually want to be center. And if for whatever reason center errors, we'll say east. But largely we're not going to be, and I'll export this exact data table and give it to you guys on the cloud. But largely it's just kind of setting up some parameters in here so we can actually test some things out. Same thing in the enemies now. We're going to go through and make those child classes. This is super simple, but I'm probably going to skip a lot of it. Basically, just like we made our enemy red, we're going to create a child blueprint, and we're going to call this enemy black. I'm going to control duplicate it, enemy blue, control duplicate it, enemy green, and if I was smart, I would have if I was smart, I would have gone in here and made my mesh and my stuff first. I thought I was duplicating red. I didn't duplicate red. So we're going to use ABP Mani for all of these, and we are just going to use Mani for all of these to keep it simple. And we're going to be changing the color in a minute. So we're going to take enemy black, we're going to take enemy blue, we're going to add the mesh of Mani and the ABP of Mani to them. Since I didn't do it before I started duplicating these. So we have black, blue, we have red. I'm going to duplicate red to make green. And I'll just duplicate green to make boss. Boss is the only one we need to set anything up in here because we need to go into our default variables because we never put it in a category and just say, yes, this is a boss. That's the only setup variable we need in this to make it sure it's a boss. It's just to check is boss. Now I'm going to need to make a color for all of these. So we have green, blue, black, and red. And how I'm going to make a color is I'm going to find this material instance. I'm going to search it in the browser. And I'm just going to very quickly duplicate these. So we're going to duplicate that. That's going to be 3. Duplicate that. That's going to be 4. 3 is going to take this base color. We're going to take the tint. We're going to make it red. I'm going to save that as red 1. And this is going to get saved as red 2. Again, same thing. Take the base color, take the tint, make it red. And then we're going to go over to enemy red and use red 2 where 2 was and red 1 where 1 was. I know 2 is on the top, 1 is on the bottom. And that's all we're going to do. So I'm just going to probably fast forward this part because I'm just going to be like making a bunch of these. Okay, and now that we've done all that stuff, I'm just going to go through this data table to make sure that all of these references are proper. So I'm going to actually just delete this reference, and I'm just going to say enemy boss, and I'm going to pretty much do that for all of the rest of these. We're just not going to be very vocal about it because we're going to be running the AC, so it's pretty hot in here. And again, you're probably going to be using your own different enemies in this game. This is just an example of a data table for us to kind of go in and test out how this is working. Okay, which enemies are being spawned? What are the weights on them? Are they being spawned properly? Is this cleaning itself up? Is it properly pooling the correct enemies? All that stuff. So this is just kind of arbitrary values for testing. And then with the enemies, let's make sure we show that in folder. With the enemies, it's basically just making sure that we have a different color enemy for each of these that we can put out into the field. That way we can like see the difference. That way we don't have to print a bunch of weird strings and look a bunch of stuff up. We can literally see which enemy is which. And the boss can just be the normal color since everything else has color. Alright, now that we have our data table all set up, we can come back into our setup. We can come back into our setup next wave now that we've got our data table all set up. So on this branch here, we need to get data table row. And we're just going to convert in this data table. I didn't really explain it very well, but our row name is always equal to a just direct number. So 1, 2, 3, 4, 5, 6, 7, 8. And we're going to take wave and basically convert wave to that row name. But we need to go to string first because we can't go directly to name. And then we're going to go to name. And that way we're getting whatever wave it is out of this spawner details data table. And then we're going to set that to spawner details since we are using the data table in this instance. And then we are going to call setup spawn pads. And this is where the spawn pads get set up. And then we're going to call calculate needs, because this is where the needs start getting calculated and all that good stuff once we figured out what we are doing for the next wave. So we're going to take this spawner details, not this one, because it might be different if we're running the false branch here. So we're either out of data table rows or we want to not use a data table. And then we're going to use the pads out of here to set up the spawn locations. And the false is also going to feed back into this. But what false is going to do is it's literally just going to take the spawner details and it's going to set members in the spawner details, and then we're going to run this. Okay? And this is all coming right off of the false. That's literally all we're going to do is set the members. But the members we're going to set are going to be kind of determined by you. For me, I just used total enemies, max alive, and is this a boss round? Because hopefully by this point you've kind of already determined what you want your core spawner details to be, like your enemy classes, if you're using weights, if you're doing spawn intervals, all that stuff. Hopefully you've already determined that by now. You may want to determine that every single round, but I didn't want to. I only want to determine these 3 values to increase every round. And this is where adding enemy complexity or enemy health values or enemy damage values can really be helpful, because we're still going to be hard capped at basically a limit on how many enemies can ever be alive or total in a round. Because there are just limits to how much our hardware can actually process, unless you're making like no skeleton meshes and not using character movement and stuff like that. But that's totally a different thing almost than what we're doing here. So we're going to take our spawner details here and we're going to break it open. And we need to run some logic on our total enemies and our max alive. And ultimately this is going to get run into a plus on both of those, right? So we're going to ultimately, both of these are going to get run into a plus. But what that plus is going to do is going to be slightly different for both of them. It's basically going to be the same thing, but it's going to be slightly different. And then we're going to need to clamp that plus between a value to make sure that we're not exceeding our game's limitations, like we were just talking about. Basically, whatever the hard cap is, you know your game is not going to perform when there's 55 enemies on the floor at the same time, or maybe you can even go up to 200 or 300 enemies on the floor at the same time, but you know at some point you're not going to be able to continue processing more and more enemies. So we need to hard cap these enemies, and those are going to be setup variables, and they're all both going to be integers. So we want one that's going to be absolute max alive and absolute total enemies. And that's what's going to be maxed out here. So total enemies is going to go into total enemies, max alive is going to go into max alive. And these are both going to be setup variables that we set up in the game mode in just a minute, because we're almost done here. Okay, we are almost done here. Now we need to multiply these or do some kind of logic to actually increase them. So I'm going to multiply both of these by an amount. And that amount is going to end up being a float. So we're going to convert this to a float. Let's say toFloat. And we're going to say toFloat. And I'm going to floor both of these. You could round, you could tourniquet. I'm going to floor both of them and use that as the addition value of whatever we're adding to this. And we want these to be different because we might have a game type where we have more absolute total enemies, and we might have a game type where we just have more absolute max alive. We want to be able to determine that. So both of these are also going to get promoted to variables, and they're going to be setup variables. So I'm just going to duplicate the setup variables, and this is going to be max alive multiplier, and this is going to be total enemies multiplier. And both of those are going to be floats. And total enemies is going to go into the total enemies. Max alive is going to go into the max alive. You may want to set up defaults here as well. Totally up to you if you want to set those up or not. If you're like always going to forget to put them in the game mode when you put this in. But adding this into the game mode is kind of like a pretty important thing. And we need to do this again. So we're going to take this exact same logic and copy paste it. And this is where we take the wave, do the division whole and remainder, and see if that is equal to 0. If that is equal to 0, it is a boss wave. If that is not equal to 0, then it is not a boss wave. So having defaults in here for like the boss class and stuff can be pretty important as well. I know that I'm using the data table to start, and we're going to have, by the end of the last data table wave, everything that we need is going to be all set up inside of this structure. If you're not using the data table at all, we'll probably want to add a function in here or in the game mode to basically determine what the defaults are going to be for this, or the starting variables. Because as you can see, we didn't change enemy classes or weights or any of that stuff, because I know by wave 13, which is going to be my max data table wave, we are going to have all of the pads active, we're going to have all of the enemy classes available, and all of the weights for debugging. But you may want to do something in the game mode on begin play to check and see if you are actually using the spawner, the data table. And I think the game mode is also a good place for that, because you might not be, you might have different game modes within your game mode. I know that sounds weird, but you might have like one which is arcade, and one which is random, and one which is curated right from your game mode. So it's something to keep in mind there. That is what we're going to do next. So we're going to go into our game, and we're going to go into our game mode. And inside of our game mode, we haven't done anything yet. So we need to actually set up this wave manager. But first, since I'm done with all this stuff, I don't want it to be here looking like this. I'm going to drag over all of it, because this is all of our start, end wave, periodic cleanup, and set up next wave, and I'm going to collapse it all to a node, and we're going to call this wave management. And we should be about done here. Now I'm just going to put this wave management up here with all the other ones, and we're going to compile save. We should be about done here. Now inside of my game mode, I need to again set up those defaults. So I'm going to click the wave manager in the components that we added earlier. And we're going to go ahead and start setting up those defaults. Some of these could be private, like the pads could probably both be private. The timers could probably both be private. You're going to have to decide what you want to be private. I don't have a problem with me needing to set things as private, because I know what I'm selecting here. But if you're working with multiple people or selling this, then you'll probably want to privatize some of those variables so people can't access them. Anyway, max data table wave, we know that is 13, so that is 13. Use data table is true. Absolute max alive, I'm going to make this is 70. And absolute total enemies, we're going to make 150, I guess. Our max alive multiplier is not going to be 5. That's going to be, 5 is going to be way too much. So we want 0.15. And the total enemies, we want 0.25. Management as well. A lot of this stuff should probably be private, but it's not. Because I don't really care too much about what variables come up as private, and I don't want to spend too much time on that. We're already going to be here for 4 hours, right? I want you to have a component before you get too bored here. We're at 3 hours 15 minutes, and I think we should be basically ready to start this system. So we're going to run a delay of like 5 seconds on begin play, just to make sure everything is loaded up. This is from the game mode, so this is going to be like one of the first things that loads. Now we're going to take the spawn manager, and we're going to start countdown timer, and we're going to set up next wave, because we haven't set up wave 1 yet. And we are going to make sure that in our defaults, wave is set to 1. I think I set that. I'm not sure if I did or not. And management, we want to make sure wave is set to 1. If wave's not set to 1, and we could do that by default, probably a little bit better, just to make sure we're never starting at wave 0. So we'll just make the default 1. That way we're not, again, starting at wave 0, because we're going to be setting up the wave. We're not going to be ending the wave, and end wave is where we increment that value, right? So before we actually get started handling the enemy deaths and stuff, we should be spawning enemies here. So let's just press play and see what happens. Okay, so we came up with those empty weights. And we see the enemy is pooling itself up there, but it has not spawned anywhere yet. So we pooled the enemies, we just never spawned the enemies. And I'm not sure why, because I have no readout here, right? We have no information to go off of to see what's happening. So I'm going to make a new folder here. I'm going to call this UI. This is going to be real quick. This is just going to be a basic, very basic widget to determine some things. So we're going to use our widget w_stats or something like that. You'll want to customize your widget however you're going to do it. I'm not too worried about it. This is just going to have a canvas panel, and there's going to be 2 elements inside of this canvas panel. The first one's going to be a vertical box. Just drag a vertical box in there. And inside of that vertical box, I want a horizontal box, and I want 2 pieces of text. 2 pieces of text. The first text is going to say something like remaining : again, this is just for kind of debugging. And the second text is going to get bound in just a second, but I want 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Because we're going to make some game state variables here in a little while as well, our player state variables, to test that stuff out as well. That way we know everything is working as intended for the framework here for it to be multiplayer accessible. So total, wave, T-score for the team score. We want something like I-score for the individual score. These are the ones that we're going to set up later. And something like money for the player's earned currency, however we decide to work that out later. And kills for the player's kills that they have actually gotten. I'm going to make this vertical box kind of bigger so that it isn't so scrunched. Size doesn't really matter here, I'll be honest. This is just, again, a simple little thing to show how we might do it in our UI for our game, but ultimately that's going to be very, very dependent on what your game is doing. So I'm going to add a bunch of spacers in between these, just so we can, again, see the stats displayed on the screen. I'm also going to add another little box for the countdown timer here. It's so tiny. Everything's so tiny. I'm going to make this bigger as well, because it's just a little bit too tiny. All right, that's a good size. Yeah, we're going to add one more thing for the countdown timer as well, and that's just going to be a border. We're going to center that. It's going to be like this big, I guess. We're going to make its brush color black. Its visibility by default is going to be collapsed. And we're just going to add text into that border. We're going to make the text something like... too big. I guess 80. This is just going to be a number. And we're going to center that number. And we're going to make sure that this border is a variable because we're going to need to adjust it during gameplay. So this is going to be border underscore countdown. And using particle effects or something would probably be better here. Niagara. We might do a bonus video in the future where we start using Niagara for this. But I don't want to build that myself. There's a plugin that's really good, so we're kind of waiting on that to decide how we're going to handle that. Because I don't think it's worth building it ourselves when there's already plugins and stuff available. So basically, we're going to need variables to kind of handle everything. But first, let's go to our event construct, which I know I just deleted. We're going to go to our event construct, and we're going to handle all of the game state bindings. So what we need to do here is get game state. Again, this is going to be directly tied to how you want to do your stuff here. So we're going to just cast directly to the game state from the event construct because I'm not getting away from casting to my game state. This is a persistent object anyway, so it doesn't matter to me if the UI has a reference to it. This is probably going to be happening inside of your main HUD component or something anyway, but this is just a simple UI to kind of show how we might do this. So yeah, this is probably going to be in the HUD component. You could promote this to a variable if you don't want to set up all these event bindings and bind things that way, so we can bind these to the variables inside of the game state. I don't want to do that because it's going to be refreshing all the time. And I don't even care to have a reference to this because, again, this is just a sample widget to basically display how we would do this in the future. And we're going to do assign events, so we're going to assign on enemies changed, assign on score changed, and I hate that it does that. Assign on time changed. I don't know why the heck it does that. And assign on wave changed. That way we can use these assign events to basically set values. So when this bound event gets triggered, we're going to promote these to variables and set them, and then use those variables to bind, because we don't want to be running this every tick when we don't need to. These things only happen when they happen. They don't happen any more often than that, right? So we don't need these things running every tick. Even though it's very minimal on the overhead, widgets get very expensive very quickly. So I don't want to be running too much stuff inside of my widgets if I can help it. Okay. So again, for all of these, time remaining is going to have to do something a little different. So I'm actually going to bind this one up here, which gives me a little bit of space. I'm going to move event construct back and put this on a sequence, even though we don't have our then one yet. Our then one's going to do stuff with the player state. We're going to promote time remaining to a variable called new time remaining is fine. Or just time remaining is fine. We're going to see if that is greater than 0, because this is going to run even when this check is done. And if this check is at 0, then we want to go ahead and hide our border for our countdown because we no longer need it. So we're going to set visibility to collapsed if this is not greater than 0, because we no longer need this countdown. And this is where we would run some other particle effect like wave begin. I had an animation in here, but again, animations on widgets cost way too much. I was looking at the Unreal Insights, and the animation on the widget was costing more than the entire pooling system. So something to keep in mind there. And also on our border countdown, we're going to set the visibility on true to just be non-hit testable self only. We could check. We could get the visibility and check and see if it is already visible and then not set it to non-hit testable, but I don't think this is a big deal. Again, we're probably going to replace this with a Niagara effect in the future because it's just even rendering this little border is less efficient than Niagara effects right now, apparently, in the engine. So something to keep in mind there. And Niagara effects just look cooler. They're easier to work with than animations in general. So all of this stuff is going to get, again, promoted to a variable. So total, promoted to a variable. Remaining, promoted to a variable. Score, promoted to a variable. And wave, promoted to a variable. And we're going to bind all of these things here. So remaining is going to be enemies remaining. This time value is going to be bound to time remaining. Total is going to be bound to total enemies. So total. Wave is going to be bound to wave. I thought I said T-score for this. T-score for the team score, which is going to be bound to score. I see I put score there. Which is going to be bound to score. And then these other three we're going to need some variables for, so we're going to go ahead and make them. We're just going to duplicate score, say I score. We're going to duplicate it again, say currency. And we're going to duplicate it again, say kills. And we're not going to be using those yet, but I want to get the bindings out of the way, otherwise I will forget. So I score for I score, currency for money, and kill for kills. I score I did not colon space. And that is more or less our UI setup. So on event begin play in my player controller, I'm just going to add that to the screen. This is the only thing we're going to be doing inside of our player controller. And honestly, you don't even need to do this, but because we want this to be multiplayer and ready to go, I wanted to give an example of how I might do this in the player controller. And again, we could bind all those events in the player controller and have it pass down into the widget if we wanted to. Or we could bind them in a HUD class and have it pass down to the widget if we wanted to. But this is, again, just an example. So we're going to create widget. That widget is going to be w_stats, the widget we just made. Make sure that the owning player is set to self. Otherwise, we're going to have no way to get the player state out of the player controller later on. And then we're just going to add it to the viewport. Okay? If you're doing sit-down multiplayer, split screen, you might want to add it to player screen instead. And this is locally controlled. It's basically going to make sure that we are only adding these on the local player controller. So the widgets, if you don't do this, the widgets can get like the server player widget ends up being all the players' widgets, or one of the other characters opens up an interaction widget, and the interaction widget replicates to all of the player controllers and just spawns on all player controllers. It gets pretty ugly. You also need to run this check inside of your custom player, but we're not really, that's not the point of this video. This is purely as an example to get this on the screen, right? So to get this on the screen, so we can start debugging it. Okay, so yeah, something is happening where our enemies are not coming back here on start wave. So let's figure out what we did wrong. I definitely goofed something there. And now that we have all this stuff categorized, it's going to be even harder to figure out what we did wrong. I'm just kidding. So start next wave worked, right? We started the spawn timer, it counted down, it spawned the enemies, they went to the pen, they just didn't deactivate themselves. So our problem might actually be in the enemy class as well. because we saw them over there, but we saw them being active, right? They were not hidden in game. So we are hiding them when we remove them, which should be happening when we spawn them. So something happened here where we possessed the enemy and didn't move them to the proper location. So the spawn location that we passed in here was probably wrong, right? Probably wrong spawn location. So handle enemy spawn. Let's figure out where we're using this, because we might have accidentally... Oh, I see what we did. Yeah, we accidentally passed the pool location when we were activating the enemy. We can't pass the pool location when we activate the enemy. We need this incoming at location. So to prevent myself, I'm going to say get at location, because I don't want to drag it across the entire world. And we're going to plug get at location in instead of get pool location, because the enemy was going to the wrong spot. They were activating in an area that was not the spawn pad they were supposed to be activating on. Okay, great. Our enemy is now spawning into the world. We did have massive amounts of clipping there. We're going to try to figure that out in a minute. I didn't have that in my first example project. So that might be coming from the async spawning. I'm not entirely sure. Let's try one more time, and we'll say stat FPS just to see if we can catch it before we actually run insights. Yes, my FPS is low. I have 2 of these open. I have 2 projects open. So yeah, there was a good amount of tear there. So what exactly happened there? I think we failed to actually spawn the enemy. So what we're going to do is when we activate the... before we activate the enemy, my bad. When we get the enemy from pool, if we spawn a new enemy, I want to print a string and say new spawn. That way I know a new spawn is happening. I'm going to do the same thing down here. I'm just going to say new spawn before this finishes. Doesn't really matter where. Just for a little bit more debugging, we probably should have done this as we made them. I just really didn't think about it. I did them in my first example project, and then I never did them again because I kind of knew everything was working. Not a good habit to get into, I know. And then here, where we are actually spawning the enemy for the pool, we're going to say print string enemy trying to pool spawn. And then when we actually spawn them, we're going to say enemy pooled. And we'll see what's actually happening. I think they're getting put in the pool. I think everything's probably fine. It's probably just my editor. I'll be honest with you, probably just my editor. Yeah, so the enemies, they both pooled, and now they're going to come in here. And yeah, we didn't get that big tear this time. I really think it's just my editor. Probably my editor and my computer. If I look at my... I also have the NVIDIA system control up as well, and it is definitely hot right now. GPU is sitting at 75%, CPU is sitting at 50%, and it's been there for a while. So let's go ahead and continue on here before my computer explodes, because I think everything is kind of working the way we want it to. Now we need a way to basically destroy the enemies as we need to, and attach the stats that happen to the player state, right? Because that's the gameplay loop. So we already have our spawner. Our spawner's probably good. So let's go ahead and start working on the enemies. So now inside of our enemy base, we still have our return to play and our remove from play, but we need a way to damage the enemy, and we're going to be using the built-in event apply, which is event any. It's too far away, I can't read. Event any damage to basically say this actor has been damaged and needs to die. And we're going to be making a simple laser beam as well. So we're going to say switch has authority because we want to make sure that this is the authority enemy on the server. It should be the authority enemy when you call this event, but we want to make sure it is because this is a server event. Just to be sure. Now we need to get this health, which should be replicated. It is. And see if that is greater than 0. We could also check active here if we wanted to, but I think checking health is fine. And if the health is greater than 0, we can actually do stuff. If the health is not greater than 0, then we've damaged a dead enemy, and we don't want to do anything because we don't want to kill them again. And this is a very simple health system. This is nothing complicated. no shields or armor or anything like that. We'll be building one of those in another series to attach to this, but it'll be its own standalone thing. So we're going to subtract, obviously, the damage from health, and we'll put that into health, so that's our new health. If that new health is less than or equal to 0, then we have died, so we're going to branch. And we're going to need to run a BPI through the player state, which is why we're using this, because we can take this instigated by, which is a controller, and get a player state from that controller and use that player state to run our BPI. And that's going to be the valid player state that we pass into this when we make our damage event on our player. So this is basically going to be our lifeline to talk to the player states to be able to do whatever it is we need to do with that. And then there's also damage types, damage causers. There's a lot of really cool stuff in here that we're not going to be using, because the whole point of this is really just to make it show on screen that this enemy is doing the right thing. This is how they're killing them, and to be an example of what you would do in your game. Because we've already done the hard part, right? We've already done the part where we spawn, we make the actor component, which is the whole point of this video, is this actor component. So now we need to basically just make sure this is multiplayer ready. So we're going to add in a new blueprint interface. I don't know why I hit blueprint again. Blueprint interface. And we're going to call this BPI play state. Because this is going to be the BPI that connects to the player state. Because I don't always know which player state it's going to be. I don't want to cast into it. I want to be able to use this even if I have a more complex player state in the future. Right? I want to be able to just plug this in and use it. And this is just going to have one function for me, because I'm keeping this simple, and that's going to be I add kill. If you want more complex personal score, headshot logic, all sorts of stuff like that, you would pass it through in this BPI play state and make basically events for it. But I'm not doing that because I'm just going to be running this I add kill message from the enemy base when I kill them. And then I'm going to try to handle death on the enemy. And try handle death is probably going to be our first server event. So we need a custom event here called try handle death. And try handle death is going to be run on server and reliable. And then we're going to call try handle death because this enemy is now dead. Okay, they have taken enough damage to lose all their health and now they're dead. So that's done. We're going to comment it, say any damage, and we'll work on this BPI in just a minute. We want to try to handle the death on the enemy first before we get out of here. These are the last two functions on the enemy. So we need try handle death, and we also need a multicast event here, which is going to be handle death. And that is going to be multicast and reliable. This is just going to take, if it is a boss, we need to destroy it. So that's just going to destroy. And I guess this doesn't technically need to be multicast. You could probably do this on the server and it would trickle down. But basically on the multicast here, we want to make sure that the clients are all kind of seeing things as quickly as possible. So we're going to set actor hidden in game just to get them out of the way and not hidden. Now I found if I set collisions disabled here as well, it kind of broke the enemy and they would do this weird car thing because of the spawner locations and stuff like that. So something to keep in mind. If you end up with ghost hits on your enemies a lot, or ever, you might want to disable collisions or tell it to disable whatever collision trace channel you're using specifically. But we don't have collision trace channels in here, so we just need to basically make sure that the actor is hidden in game as quickly as possible so that the other clients aren't still seeing that actor, because it does take a second for things to trickle down from server authority events. So we're going to say switch has authority, especially if you're running this from a client. And switch has authority. The first thing it's going to do is handle death, which is that multicast event. Because again, we want this to be going as quickly as possible. We'll run whatever other logic we need to run after. But we know that the enemy has died, and we just want to make sure that that is very quickly being multicast to everyone so that enemy gets off the screen. Now we're going to get the game mode, and we're going to need a BPI for the game mode as well. So let's go ahead and make that. So just like BPI play state, we're going to make a blueprint interface, and we're going to call this BPI game mode, or whatever you want. Again, this is just to simplify uses later. I don't have to import my game mode. I don't have to do anything like that. So we're going to say I handle boss death and I handle enemy death. And both of these are going to take an input of an actor because we need to know which enemy is dying. So this is an enemy, and this is in boss. And I'm going to give those a category called BPIGM or IGM for short. That way they're out of the way. I'm also going to give the game state one its own category of IGS for iGame state. IPS, my bad. IPS for iPlayer state. And yeah, now it'll have a category. So now inside of my enemy base, I'm going to call game mode, and I'm going to call that I handle boss death. Now, I know we haven't implemented it on our game mode yet, but we're about to do that in a second. And then on the false branch, we're going to say I handle enemy death, and both of these are going to take self as a reference. We're going to drag it here. We're going to say self, and we're just going to pass self in this one as well. That way we're calling the game mode, and the game mode is going to tell the components, the spawn manager components, to tell the enemy to go back home. I know it's a little roundabout, but basically this is just making sure that the authority is always in kind of control of our game, and our enemies are reliably going through the actor component to pool themselves, to unpool themselves, to handle their own death events, and all that stuff. So that's going to come back through. We'll show that now. Our class settings here on our game mode, we're going to implement that BPI game mode, and we're going to implement both of these events from that game mode, and this is going to be pretty simple. We're just going to take the AC wave game manager, and we're going to handle boss death and handle enemy death respectively. So handle enemy death, handle boss death, and that's just going to use these. We don't actually need the enemy ref for the boss class, but we do need it for the enemy death. I thought I did this, so... Oh, that's right, we use something totally different for handling the enemy death. This is where I always confuse myself. I'm not great at naming things. I know, you probably hate me by now. But we're going to call kill enemy instead of that, because kill enemy handles the enemy death and deactivates the enemy, and this is happening on death. So we want to make sure that we are killing the enemy. So we're going to drag it here and say, now kill enemy. Instead of handling enemy death, and then handle enemy death is going to get called from kill enemy. And handle boss death just does its own thing because we're not pooling bosses. So I know that's probably a little confusing for you. You might have to name things better if you don't understand what you're doing, like me. Don't be like me, name things appropriately. But yeah, that is all that's going to happen. Basically, we're just making sure that we are telling the game mode, hey, game mode, it's time for me to die. I don't have any more health. I need you to tell the spawn manager to handle my death so that the spawn manager can handle the death. It knows the enemy's died. It can update its functionality through handle enemy death to see if we need to restart the timer, if we're done with the timer, if we need to end the wave, whatever we need to do, which is all happening inside of that actor component, which is on the game mode, which is why we made it that way. So now it's very easy for the enemy base to call the game mode with this BPI, any game mode that runs this BPI, and say, hey, you need to handle my death because I'm dead. And the multicast is just to make sure they're instantly hidden or hidden as fast as possible on every single player. That way they're not ghosting around. And again, if you're using special line traces, which is definitely something you're going to be doing if you're making a game like this, is probably using a line trace by channel and having custom channels on your enemies, then you'll want to make sure that you are doing this. So there were a couple more things in here I wanted to do before we close out our enemy. And those actually deal with collisions like we just mentioned. So for the collision presets on our capsule component, we're going to keep most of these the same, but we're going to make it custom. And we're going to make sure it ignores the camera. Okay? Ignores the camera. Otherwise, it's going to get in the way of the camera when the enemies are running around. Same thing with the character mesh. So the skeletal mesh component, the collision presets, are set to character mesh by default. We're going to make those custom. And we're actually going to block visibility and hide the camera, because we're going to be using just visibility as our line trace for our damage effect from our enemy, or from our player, which is going to be the next thing that we build, and probably one of the last things. So we're going to build that in our player. We're going to take our actions. We're going to make a new action. So we're going to go to right click, input, input action, and we're going to say IA beam attack. IA beam attack is just going to be a digital bool triggered, so that's fine as it is. We're just going to save it. And then we're going to go into the IMAP and add that mapping, IA beam attack. And I'm going to add that to the left click, so left mouse button. And we're going to save that. We're done with it. We don't need it anymore. We actually probably don't need our enemy base anymore. We probably don't need either of these BPI anymore. We definitely don't need our player controller anymore. We definitely don't need the widget anymore. Well, we will need the widget in a minute. And I don't think we need our game mode anymore either. We definitely don't need this data table. So we're going to go into our player, and we need to create first a Niagara particle effect to show the beam. So we're going to say FX as a new folder. And we're going to keep this as simple as possible. We're just going to right-click Niagara system. And we're going to make this dynamic beam here. And we're just going to mod it a little bit. So NS beam attack. I don't get too deep into Niagara. I usually buy Niagara because it's pretty cheap. But Niagara is a pretty cool thing if you like getting into it. I think it's more intimidating than a lot of people. A lot of people don't give it a chance because it seems intimidating. So what we're going to do is we're going to take the loop behavior and we're going to put that on once instead of infinite. Otherwise, this beam is going to go forever and ever. We're going to set the loop duration to 3. So we want this to go for 3 seconds. The beam end is actually going to be something like 2500, or basically the length of the attack that we want to make. So how far our laser beam is going to project. I'm going to decrease the spawn count here, which is going to make it a little bit thinner. I think 20 is fine. This is not, again, good practice or anything like that. We just literally want a beam attack to look cool. So I'm going to make this scale curve 80. That way we have a thicker beam. I know we're going kind of fast here, but that is the scale curve. Again, we'll just go through this again. Our emitter state, the loop behavior only once at a fixed duration of 3 seconds. Our beam end just gets increased to 2500. Our spawn count goes to 20. And we come all the way down here to the beam width curve, the float curve, and we make that 80. And then we come down here to the color, and this is where you'll add whatever color you want in. You're probably going to want to compile save first. And then you should be able to manipulate the color to whatever color you want. I'm going to do just like green here. I think that's fine. And we're just going to compile save that. That should be good for our beam. That's all we're doing, is we're just modding that beam out a little bit. So now inside of our player, when we have our input action for our beam, we're going to say IA beam attack, and you want this enhanced input action here. We need to fire the laser, right? We need to fire the laser. And we're going to do that on a run on server event, kind of like we did in our enemy. We're going to make a custom event called try fire beam. And this is just the way I do it. A lot of people do these differently. Try fire beam is going to be a run on server event, and we're just going to try fire beam on triggered. You would probably want logic here to say, okay, is fired duration, probably use a gas system, right? All that good stuff. If you're into that, I won't use a gas system. I'll just use a simple cooldown trigger to say if I have fired my beam in the last 3 seconds, then I can't fire my beam. But we don't need to do any of that here because this is literally just a way to kill enemies. And killing enemies with just the one key is boring, so we made a laser beam, right? We made a laser beam. So we're going to need an array of hit actors here that we're going to have to clear, but we also need a multicast event as well. So we're going to make another custom event called beam effects. And this is where you're going to put the Niagara and basically everything that needs to get multicasted cosmetically. So the sound effect, the Niagara, all that stuff. For us, we are just going to spawn system at location. We're going to do this like as simply as possible. And we're just going to say this is the Niagara system beam attack that we just made. And I am going to set custom time dilation to 5. Because I feel like this makes it move slower and look better, even though it still only lasts for 3 seconds. I think it just looks better this way. Again, this is the multicast, so this is going to get basically run on every client that is around to see it. And we need one little function here to basically determine where this is going to get fired at, the location and rotation. If we do this, we'll do that later. So we'll do try fire beam first, that way you can actually see it. So if we have authority here, we need to do a multi-spear trace by channel. Again, this is when you make your game, you'll probably want to have custom channels in here. For now, we're just going to do the channel on visibility. We're going to make the radius something like 40, and we'll be running a little bit of logic to get the start and end. But basically, we just want to say debug for duration, and we want to fire the beam effects before that. Because the whole point of this is actually that we're going to see the beam effect, and then we're going to make this to figure out where we're going. We're going to take out of the hit effects. We're going to make a for each loop. And with multi-sphere traces, you kind of have to make sure that you make some kind of localized reference to your enemies. So what we're going to do here is we're going to take the hit actor. We're going to say does object implement interface. And if this implements BPI damageable, which would also probably be for... No. Okay. Probably also be for our damageable enemy or actors in the future, like if we have walls that can be broken through or something like that. We're going to see if it implements BPI damageable. If it does, then we need to basically promote it to a variable. But we don't need a single variable. We need an array of hit actors. And what we're going to do is we're going to get that, and we're going to add unique. That way we're only adding one instance of this hit actor into this array. Because, again, it'll add and add and add. If we just use this, then it'll hit the same actor multiple times. And we don't want that. We only want him to get hit once by the beam, unless you're making an annihilation beam. Honestly, it doesn't matter too much here, but I wanted to have an example in here for you guys of what you might do if you're using a multi-sphere trace, right? So when that is done, we're going to take this hit actor, and we're going to run that through a for each loop. And every single actor that we hit, we need to apply damage, which is that built-in function we made on the enemy. So that's going to trigger that event on the enemy. Because I gave the enemies 100 health, I'm just going to say this is worth 25 damage. The event instigator is going to be get controller. This is not get player controller, this is get controller, because this returns a controller object reference. If we get player controller, we won't be able to pass that in and use it properly. I don't feel like we will anyway. We're just going to get controller, that way we're getting the literal controller, not the player controller. And from that is where we're going to get the player state, and this is still going to be the player controller that's set up inside of the player. The damage causer here is going to be self, and if you want to add damage classes in later on, you're free to do so. But again, this is just a kind of a simple little example here. Like we would add like maybe a fire effect or something for a laser beam, but I don't care because this is just a way, again, to basically say this player, this server player, or this client player applied damage to the enemy died. We're going to very simply just credit them with that kill. And that is just an example of how you would implement multiplayer. It has nothing really to do with this tutorial. Like I said, this tutorial is pretty much already done. It was done when we finished that component. So we're going to take this hit actor, we're going to clear this out. And on authority, and once we've cleared that out, we're going to do the beam effects, and then we're going to do this multi-sphere trace by channel. So the beam effects, now how we're going to do this, and again, we're going to be collapsing this to a function in just a minute. But we're going to get the mesh, and we want to fire this from the eyes. So basically like an eye laser, right? So we're going to run out of the mesh, get socket transform, and the socket name is going to be head. You could use neck or something else, pelvis, whatever you want to use, something attached to the mesh. It really doesn't matter. This is going to be totally up to you. This is where I want the beam to come from. But if I just break this socket transform and I say, okay, I want this beam to just come out of my head, which is the bone I'm using, with this location and this rotation, then when I come in here and I press my left mouse button, this should all be working. When I come in here and I press this, it's going to just fire the beam out of my head. I don't want it to fire the beam out of my head. Alright, that's weird. I don't want it firing this beam out of my head. So we're going to make a little function in here that basically just says, gives it some rotation. So we're going to collapse these to a function. This is going to be a pure function, and this is going to be called get true head lock and rot. It's going to be pure. And that's what's going to be passed into this beam effect. So we're going to run a few calculations that I already know work just to expedite this. You'll want to run your own calculations based on what bone you're using, figure out what the rotation needs to be for your mesh, for your player, and get that all locked in, probably. If you have dynamic stuff, then you'll have to handle that accordingly. But again, this is just a simple kind of debug laser beam. So from the true, once we figured out where the true is, that's going to be where the start is on the multi-sphere trace. But we need to add something to it to get an end. And to add to that to get the end, we're going to need to take this rotation. We're going to get the forward vector of that rotation. And we're going to multiply that by whatever we want, probably the same as our beam length. So that's going to be 2float. So just right-click the this and say 2float. And we want that to be 5,000 or 2,500. I think 2,500 is probably a good place to start. And we're going to add that multiplied value of 2,500 to this and make that the end. So hopefully that makes sense to you. Again, this is just kind of firing in a direction. We're just getting the direction and modifying it. Because this needs a start and an end. This doesn't need an end. This just fires in a direction. Okay? So get true head, lock, and rot for me was pretty simple. All I actually needed to do, the location was fine. I just needed to transform the rotation. Really, there wasn't much point in even making this a collapse function. I just had to do it twice. And if I have to do something twice, I'm a lot more likely to make it a function. So I'm going to break this rotator here, and the pitch and the yaw are going to be this, or the roll and the yaw are going to be the same, and we're going to just subtract 90 on the pitch. Because again, I got it in there, right? We looked at it, we saw that it was coming out of the top of the dome, so if we add minus 90 on the pitch there, it's going to be coming out of the front of the dome and not the top of the dome. And that's also where our line trace is going to be coming from as well. So I'm going to press play. And now we have our laser beam, it's firing, and our line trace is firing about to where the laser beam is ending, which is what we wanted. That's cool. So now we have this laser beam in the game. Obviously, it's very resource intensive. And when I hit enemies with it, we destroy enemies, and hopefully we progress to the next wave. And I'll start doing this on the client as well, that way we know it's kind of working. We allowed overspawn on wave 2, by the way. So yeah, that capped up the max enemies at 5. And if we kill this enemy, then we see that overspawn worked. A lot of frames got dropped there, though, which is unfortunate. I have these blue enemies, and I probably should have made the laser beam more destructive. But yeah, the blue enemies are working. Green enemies are working. And it probably helps if I'm not directly looking at the enemies where they spawn, because when you're looking at things in Unreal, it tends to take a lot of resources. So if we spawned these somewhere out of player sight, it would probably be a little bit less resource intensive when they come out of the ground there. And yeah, I mean, it looks like everything's working. Let's make sure boss is working as well. So I'll probably fast forward through a lot of this to try to trim down the size of this video. I know we're sitting at about 4 hours. And I'm about done here because it is getting really, really hot in my house. It's like 85 degrees in here. I need to run the AC. I know, it's in March and I need to run the AC. Okay, so the boss did spawn. And then we just pulled up a whole new set of enemies. That's good. That's what we wanted. We did have a huge frame drop there, so I kind of want to figure out what that's all about. But otherwise, it looks like everything's working pretty much as intended. So now we actually need to work on the game state variables as well. Or the player state variables as well, my bad. And now we actually need to work on those player state variables. So I'm going to open up the player state custom. I'm going to open the full blueprint editor. I know I have my AC on. It's really hot in here, and I'm starting to feel sick, so make sure I turn the AC on, otherwise I'll be down for the count. And we're going to add this add kill in the player state. Because remember, when we kill the enemy on our enemy, hopefully I implemented this. I might have forgotten while we were doing it. Again, it's getting really hot in here. Yeah, we say I add kill on the player state of the instigated by. And when we pass that in as the player, when we actually fire the beam, that instigated by is being passed in as the controller, which is going to be getting this player state and using this BPI. So we need to add some kind of logic in this player state BPI. And we need variables to make that work. So I'm going to add, just like we did in the game state, kills, which is going to be an integer. player score, which is going to be an integer, and currency, which is going to be an integer. And I'm going to make all of these things rep notify. So we're going to say rep notify, rep notify, rep notify. And just like we did before, we're going to say on kills changed, on player score, all passing through integers. So new kills. So on score changed, new score, on currency changed, new currency. And we're going to put those in all the reps. So on rep currency is going to call on currency changed with currency. Player score is just going to call player score with player score. So on score changed, player score. Let's call this on player, just to make sure we don't get confused with on score changed from the game state. And on rep kills is just going to call on kills changed. We're going to call that, and we're going to put kills in the variable slot. So make sure everything's plugged in and ready to go. Looks good. Now in our event graph, we need to get our kills. We need to +1 our kills because we added a kill, and set our kills because if we increment it, it's not going to pull that rep notify out for us. We'll have to set it again. So we might as well just add one and set it. Then we're going to take player score. We're just going to cheese this. We're going to say player score +5. You're going to want to add whatever scoring logic and stuff into your game. This is just an example, and we kind of want to finish here. And then we are going to set currency to basically the same thing. Currency +5. It should pretty much match up with player score. We'll make it like +3. That way we know we're getting the right variables all set up. And now inside of our HUD widget, so we're going to compile, save everything inside of our, not HUD widget, our stats widget, which is basically our HUD widget. On this second sequence here, we are going to get owner, which is get owning player, which is gets the owning player controller. Remember when we made this widget, we passed the player controller as the owning player. We're going to get game state, or sorry, we're going to get player state, and we're going to use that to cast to player state custom. But first we need to check and see if this is valid, because this might not be valid yet. So that's the first thing we're going to do on the then one. And if this isn't valid, we're going to delay 2 seconds, or 0.2 seconds is fine. We're going to say not valid play state. That's going to try again. Basically, we just want the print string to know how many times this is happening, and if it's like happening infinitely, then we have a problem. But it's probably not going to happen infinitely. And then once that is valid, we're going to cast to the player state custom. And from that player state custom, we're going to assign event on kills changed. We're going to assign event on currency changed. And we're going to assign, you guessed it, event on player score changed. We're just going to plug them in, straighten them up, and set those variables. So kills, score, and currency. And compile, save that. And now when I come in here and I play, I should be adding those to the server score or the client score respectively. So we saw that it took a few seconds to update, and then it updated, and now we're going to do that. So when I kill these enemies, it adds the score and the money to the client and not the server, so it's properly adding it to the right player state. And when I do this from the server, it properly adds it to the server and not the client, even though it's the same amount now. So we'll just kill 2 more enemies. I know, because everything kind of weighs the same. We'll destroy those 2 more enemies and see that the client is still at 10.6.2 and the server is now at 20.12.4. So everything is adding in properly via the game state like we wanted. Now to test the Unreal Insights, we're going to open the Unreal Insights session browser. And again, we are done with the tutorial, I believe. We did want to check a couple things at the end, but more or less, we're done with the tutorial. I think everything works. I don't even really need to... I need to check, but I don't think I actually need to check. We're going to put number of players down to 1 so we can get a better test, and we're going to say standalone game. And this is still not going to be a very good test because of how much stuff is running on my computer. But basically, I want the Unreal Insights to start this trace, which it has. We are now on a live trace. And I just want to go through wave 1 and 2 to see where this is kind of dropping off so hard. Okay, so nothing really happened here. Obviously, the laser beam kills it. Absolutely goes down to 60 FPS when the laser beam is firing like that. Because the laser beam is huge. Laser beam is not for efficiency. Laser beam is for going blah. And I don't see that major frame rate droppage yet, so I guess we'll just go on for a little bit longer. So it looks like the boss did fail to spawn at its boss pad, something we might have to look into. But I didn't even notice a big frame drop when we just loaded in 35 enemies. It's still not as bad as the laser beam, right? Still not as bad as when I fire this beam and it goes down to like 50. This beam is not very efficient. This is our Giga OP laser beam. Okay, so it looked like there was some frame droppage there. I definitely felt a stutter. Okay, and we can see that past wave 13, which was the last data table wave, our game is still running. It's still spawning in more enemies like it's supposed to. And we're just going to go ahead and crush all of them. And we should be capping out. Maybe not this wave, maybe the next wave. Maybe this wave. I think I capped the total at, what, 70? Or max alive, maybe I capped at 50 or 70? And the total I capped at 100 and something, I think, because I'm crazy. I'm not going to lie, I don't remember. I know we just did it, and I don't remember. So yeah, I mean, I still don't see any major FPS drops coming from the pooling system. This is largely all coming from the character movement. You can see it's steadily going down the more enemies there are trying to move around in the world. And yeah, we hit max enemies, so this should be 50. I wish I'd put a key in here to actually kill them. But yeah, it hit the maximum allowed alive, and then it came back, and then we started spawning more. So I probably could have printed the current number of live as well for better debugging, but I think it's working fine. It looks like it's working fine to me anyway. And with this many enemies in this small of an arena, yeah, they're going to get gunked up. We don't have advanced enemy AI, so they are going to get stopped up here. But you know, they're in the world, they're running around, they're doing what we want them to do. The spawner system, I would say, is working as intended. If you want to get down and dirty with your math, again, I'm not a mathematician, and make sure that your weights are all working properly. That is something you can totally do. Now you have a baseline to work off of, so you can always come back to this project. Make a copy of it, make your adjustments in that copy, and then you can come back to your hard project and basically have something, if you fail, to roll back to. Alright, so let's go ahead and open that trace. That trace is huge. Just because we do want to show off the Unreal Insights before we leave today. I know I'm 4 hours into recording, so probably at least 3 hours into the video. And that's going to open like a new sub-browser for the Insights tool. We're going to load that up. And we're going to see some spiking. And I want to know what this spiking is, even though these outliers are probably not the best things to base what you're fixing off of. I would say what you're fixing off of probably in these yellow here, in this area, is probably the ideal position to be figuring out what's going on in your game. But yeah, we get these spikes sometimes. And I think those spikes are probably wind pumps. So you can, I should explain this. You can click a thing, and then you can click F to lock in on the frame. It kind of zooms in on the total frame. So we're going to do that, and we're locked in on this frame. And we're still in the GPU here. And this is the game thread, this is the GPU. So, yeah, nothing really happened in this frame on the GPU. So it was all... basically, it was all these on-loadeds from pooling the enemies, I guess. It was all these onloadeds. That's what it looks like to me anyway. It's where we begin that deferred actor where we're spawning them async. Is where this is all kind of coming together and causing that frame tear. And this wasn't happening in our other example project where we did not do async. So async, not always entirely better. But we can see here on just like a general frame, if I click on one, we come into it and a large portion of this frame, the largest portion of this frame, is waiting for all these character movements to complete. And that is just largely where a lot of this is kind of coming from, is that character movement. So the more enemies you have, you're going to have to balance that out. And if you have a lot of enemies, you're going to have to do some group movement stuff to basically get them not moving around so much. Like this next frame is 15. So we want to come over here and check out this frame. And this frame again as well is mostly movement. So one thing I totally forgot to do here, and we will do at the end of this episode, is make sure that we are actually calling some kind of way to remove the enemies if they get stuck on the spawn pad, if you remember where we checked the debug. Even though I haven't had this issue yet, we're going to go ahead and make a way to handle that. And we're going to do that through the BPI for the game mode. And we're going to say, I bugged enemy or something like that. And we're just going to pass directly that actor class reference through to the game mode. Because we can't just destroy the enemy, unfortunately. If we try to just destroy this enemy here, which, if you remember correctly, this is running when another actor is on the pad. So this other actor that we have, if this is, if we call destroy actor here, or something like that, it's going to mess up our game because we have pooling logic, and the pool thinks that this actor is still valid in the pool. So what I'm going to do is I'm just going to get the game mode here, and I'm going to call that message we just made, I bugged enemy. And I'm going to use this other actor as the enemy that is bugged. And then we're going to go ahead and carry on with our lives. And now inside of the game mode, I need to implement that event, so I bugged enemy. And we need to do something in our wave game manager to actually handle this. Actually, we'll just handle this, yeah, we'll just say kill enemy for now. I don't think this is going to be too much of an issue, where we need custom logic to basically say this enemy needs to be destroyed. We could say destroy enemy and remove them from the pool and do all that stuff. But I think just killing them will probably be fine. And what I'm going to do to test and see if this is working is I'm actually going to go into my enemies, the AI controller, and I'm just going to unplug this so it's not doing anything when it gets possessed. Now when I press play in here, they should spawn on their pad and then sit there. And they all destroyed themselves. Great. And the boss did not spawn where we want the boss to spawn. So let's figure out what's going on with that boss pad on the boss wave. I already have a pretty good idea of what's going on. I don't think I named this the same thing as I named it in the data table. I did not name it the same thing that it was named in the data table. So let's go ahead and put our AI enemy controller back together, and we will start testing this boss. Hey, the boss spawned where we wanted it to. Yay! So yeah, let's also go ahead and take off the debug on that laser beam so it looks a little bit cooler. And that is just when we are drawing the laser beam, we're going to take that debug and say none. But I generally think everything is working the way we wanted it to. We just wanted to make sure we put that bugged enemy thing in there to make sure we're doing something with the bugged enemy. Now, if you're having a bunch of issues with your implementation, maybe like you have certain enemies that just keep spawning in and getting bugged every time they spawn in, or you don't want to kill the enemy for some reason, you could make that logic in the wave game to basically say this enemy is going to get removed from this pool, It's going to get destroyed, and then we're going to take our counters, and basically see if the spawn timer is still active, try to spawn another enemy. But I think we've done enough in here. I think this is good, and I think we're generally not going to have issues where a stuck enemy is actually, like, permanently stuck. If they're stuck for some reason, maybe they didn't get their controller reference properly, or maybe they just got stuck, then killing them should work. And if we're constantly getting stuck enemies, then it's probably an issue of where we're putting our spawn pads, or maybe our collision settings in our world, or something else, most likely, anyway. One more thing to note, inside of our Wave Game Manager, when we load our assets, we pretty much always load them, and then cast them, and then spawn them. You could cache this actor and not have to load this every single time. So you could put this over here in the first loop and cache it, and then not have to load it every time. But honestly, I had some issues with that, which is why I just decided to kind of leave it this way. I just spent like an hour testing some things out, and it ran worse. Basically, trying to make sure that we were hard casting or saving this variable. So, something to keep in mind there. So, one more thing I wanted to add in here. I noticed while I was editing my video that we were still calculating our needs on boss waves when it is only boss. So if you want to, inside of your setup next wave function, before you calculate needs at the end, you'll check if it is a boss wave and only boss. If that is true, we don't want to do anything. If that's false, we want to calculate needs. So if it's not a boss wave, or if it's not only boss, we need to calculate our needs for the wave. But if it's just the boss, we don't need to do that. Thank you for watching. Consider joining our Patreon. For just $3 a month, you'll get instant access to all of the project files and the videos as soon as they come out. Now, on to the next one.